terrible, though. You may have trouble getting out.
I think we can start the training. Hello, everyone. Thank you all for taking the time to attend the second three of the trainings organized by the UNEC team. Also, warm welcome to the guests who managed to join us online. This is the first day of the trainings, and the title of training is Design Efficiency and Renewable Energy Projects. We are very pleased that within the Green Finance Facility project, the time has come for all of the team members from the project consultants team and the verification consultants, independent assessors to come together and to attend these trainings. I believe that our expert team will provide very valuable information and very useful know-how experience will be transferred during the trainings. And I'm sure that all of us will leave the trainings with additional knowledge and experience in terms of the connecting areas which will be covered during the trainings. The welcoming address will be given by Ms. Susana Dujak, a UN resident coordinator in North Macedonia. Thank you, Ms. Dujak, for taking the time to join us today and to give your welcoming address.
So good morning and welcome. Dear colleagues, dear government partners, dear bank representatives, and dear UN colleagues and EBRD colleagues. It's really a pleasure to be here with you today, which is the start of the training for the Green Finance Facility project and the verification consultants. As you know, the Green Finance Facility is a collaboration between 3 UN entities, UNECE, IOM, and UNDP, with EBRD and several commercial banks in the country. And the aim is to accelerate energy transition, including among the groups of society who are not always the first comers in this process. We therefore look ahead with great anticipation and eagerness to see the results of the Green Finance Facility in terms of reducing greenhouse gas emissions and air pollution, and also ensuring a just energy transition. So your role as consultants is really central to the success of the Green Finance Facility. Renewable energy and energy efficiency are relatively new technologies on the market, requiring both engineering and financial and business planning know-how in order to right-size the investment and choose the most optimal renewable energy and energy efficiency solutions, because there are various options. The small and medium-sized enterprises and households depend on your expertise to be able to shape their investments in the most efficient and effective way. Also, the banks rely on you to assess how adequate are the investments, and is it really fulfilling the stated outcomes and targets in terms of greenhouse gas emissions and air pollution reduction. So we very much count on you and your expertise. I think the training today is an important milestone in that direction. And I hope it will allow you to have the most up-to-date knowledge on renewable energy and energy efficiency technologies that you can then transfer to small businesses and households. This is a fast-changing industry, so therefore knowing which technologies do what is actually really important part of the process. I know that you'll use the knowledge you gained today beyond the Green Finance Facility, because we see you as an important resource for the country. It's not just about the clients that you will be helping in this project, but you can also help others in the country make proper decisions in terms of these investments. So let me really use this opportunity to thank UNECE for their engagement and for identifying and bringing the best regional expertise on renewable energy and energy efficiency to North Macedonia. And let me also thank UNDP, IOM, and EBRD for their continued dedicated work on this project. And of course, to thank our government partners, the Deputy Prime Minister's Cabinet, the Ministries of Environment, Economy, and Finance for their close partnership. So I hope you have an inspiring training and many successes in your work with small businesses and households and banks. Thank you.
Thank you, Jack, for your welcoming address. And I would like to ask the meeting participants to give a short introduction before
opening from ECE.
yes, you want work with Oleg would like to take the floor first.
Yes.
Okay,
A few apologies, a few welcoming remarks from UNEC as the organizer of this training. My name is Oleg Zubinsky. I'm regional advisor in the Sustainable Energy Division of the UN Economic Commission for Europe. We are very happy to be part of this project, Green Financing Facility, and UNEC's part is in fact focused on working on improving national capacity on renewable energy and energy efficiency technologies for small and medium enterprises and households in North Macedonia. We are very pleased with our cooperation with other partners, with UNDP as the lead, and with IOM and EBRD. We believe that UNEC brings its knowledge and expertise to this project in the area of energy efficiency and renewable energy, both in financing, but mostly in capacity building that is related to investments in energy efficiency and renewable energy. We have been working on this topic for several decades already, so quite successfully, but we still see that work is still needed to make these kinds of investments business as usual. And as Rosanna rightly said, with this project, we're trying to bring these measures, which are in fact cost effective, which are in fact bringing many benefits, both to the recipients of these measures and to the society as a whole, bringing them to those who are what we call underserved. So those businesses and households who may not be able to get this otherwise. So some assistance is needed. And what we are trying to do in these 3 days, 2-day training for the project design consultants, and then 1-day training for verification consultants, in fact, is to share our knowledge and knowledge of our consultants and get familiar with our colleagues soon, to bring that to you so you can be more effective in dealing with the clients, with the customers. So that's our goal, and we hope it will be successful. We have been engaged in this project for almost 2 years now. We will continue to be engaged. Our we call it active engagement in this project in a way ends, but we want to be still involved, and we're thinking of possibilities to bring some of our own funds and capacities to continue being involved in this project. So with that, again, thank you very much for coming, and thank you for Skopje. While the weather may not be very welcoming, we know that people here are, in fact, very hospitable and welcoming, and thank you all. And thank you personally to Rosanna and Lilian and UN colleagues here. And later, my colleague Nadezhda Khamrakula will speak a little bit more about the project, but now back to Maria. Thank you.
Many thanks, Oleg, for your welcoming address and for sharing some more information and details as to what you expect to receive in 3 days of trainings for the project implementation consultants. Before we move on to the objective of the training program, which will be shared by Ms. Nadezhda Khamrakula and Mr. Deochevich, I would like to shortly ask the meeting participants if they can briefly introduce themselves and possibly say the name, surname, and the organization that they're coming from. If you wanna share a couple of more details, that would be very much welcome, so that we all know who are the persons that are sitting on the table and will be joining us for the first day of the trainings. Thank you. I can start. So Maria Volnova-Kostevska, Project Monitoring Communication Associate within the UNDP Green Finance Facility team. Thank you.
Steven Belewski, consultant for partner financial institutions relationship manager. Project manager Solomon.
General manager Solomon.
Sasha Palovsky from Center for Energy Efficiency Research.
Diana Koyosova from EBRD, I work on the green finance facility.
Vanessa Pomaralo, Junior Coordinator Associate for Corporate Clients from Sparkasse Bank. Lina Nedevska, SME Relationship Associate from Sparkasse Bank.
Nadezhda Humrakova, Economic Affairs Officer from the United Nations Economic Commission for Europe. Lilian Kandikian, part of the Office of the UN Resident Coordinator, and supporting the coordination of the Green Financing Facility project.
Vancho Popov, I'm business consultant. My own Popov management consultant.
Anna Kubelka, Female Project, it's an engineering company.
Dragan Blažev, I'm Female Project, partner organization to the consultant that is implementing now the green financing facility for SMEs. My position is lead engineer for this facility.
Filip Mielewski from Ministry of Finance, Department PAU for Public Sector Energy Efficiency Project. I'm civil engineer expert there. That's it.
Vladimir Tomski, Barica, I'm the team leader for component 2 as independent assessors.
Ivan Nevzatny, UNDP, monitoring associate in project scaling up actions to tackle air pollution.
And Beltrovicev, you have pleasure to listen to days. And I'll say to you. Thank you.
I'm Zahoria Shishkovska, Project Assistant at the Green Finance Facility. Thank you all.
Online.
Online. Okay, we have some people who have joined us online. Maybe we can take turns and you can raise your hand. I just want to go first and then we can unmute you and you can take it to the welcoming and introduction part. If anyone wants to go first, please feel free to raise your hand. Otherwise, we'll have to use the alphabetical order as usual. We would ask Antoneta if she can unmute herself and give a short intro.
Antoneta Manova Stavrovska, Economic Chamber of North Macedonia.
Thank you, Antoneta.
Risto Ivanov, Creatia Organization, business consultant and energy efficiency consultant.
Thank you.
Ivanka Stepanovska, communication and marketing expert for Green Facility.
Good morning, Perica Vrboski from IPP Advisory, business advisor to SMEs.
Okay, let's go next. Sasha, Natasha, Lucy.
Hello, I'm Natasha Ljubitsky-Angelic. I'm sorry, I was very much interested to come in the UNDP office, but unfortunately, due to the OPS big conference, it was almost impossible to reach the office. So therefore, most probably we will follow this training online fully. So as I said, I'm Natasha. I'm coming from a private consulting company called MCG with over 20 years experience working with the private sector, business consultant.
Thank you, Natasha. Bogdan, would you like to go once again because we couldn't hear the person?
Yes.
Yeah, Sasha Listowski, also coming from MCG consulting company, working there as a project manager.
Thank you. We have 2 more introductions left. Madam Chebilyatska, Ilona Stefanovska, Ilona, sorry.
Hi, Ivanka Stefanovska, communication and marketing expert for Green Finance Facility.
Good morning, my name is Dan Chebilyatska. I work as risk manager at Sparkasse Leasing.
Thank you all for the short introduction and also thank you for taking the time to join us online today. Before we move on to the next section, if you have any questions, this is a reference to the online attendance. Please either feel free to raise your hand or post a question in the chat box. And we will be looking into the chat box throughout the whole session. And Mr. Delcho will be answering your questions immediately upon their posting online.
If I may, before we go on, Antonetta speaking, there is an echo in the room. Where are you? So maybe the technicians can make something in order to sound to be better. Thank you.
Thank you for the remark, Antonetta. We'll look into it right away. Thank you. Okay. My affairs officer at UNDC will take this hand.
Thank you. Maybe before that, I just want to say that in addition to the trainings, UNEC was actually, UNEC's involvement in this project also included a work which was done on the revision and update of the database of the high performing household equipment and materials. That was done by Sasha Panevsky, who was involved as a consultant into this update. So this was one of the activities. This update is update of this technology selector tool is actually available on the UNEC website. If you are interested, I can provide the direct link to this report, this information. It's actually quite comprehensive update of the equipment and materials, so you can consult on this. And as Oleg mentioned before, the second bigger component of our involvement is the preparation and the conduct of the trainings. So these trainings are today on the design of project renewable and energy and efficiency projects and on the verification projects that will be held 30 November. Maybe already doesn't need the presentation because I kind of moved on. So yeah, I wouldn't do this. It's fine. So the objectives of this training was actually to work with you, consultancy companies and consultants who would further help to prepare the bankable project proposals. So our goal that in this case that actually this technical assistance will help to support the project design process in principle, that it will be actually spread and that it would contribute finally to the project outcomes and to using the best technologies that are available in the market. And this is also related to what I said before, the update of those technologies is also available now. As for this training, we started from the preparation of the outline that was done by Delcho, who proposed, and in consultation with some of you, it was developed as further all the training materials and training curriculum. These training materials will be available right after the training, also on our website, and you can after consult all the materials that will be presented today, but then you can also always look into them and refer to them in your further work. After the conduct of the training, we will also aim to have some consultations if you need that will be provided as online consultation related to the design of projects, right? Dacia. You can probably say this later on. So the process, the idea that we start this process, but we also continue helping you and other training participants also to follow this process until the projects meeting all the criteria to be considered as bankable projects. So this is in terms of the general overview. I know that today and tomorrow we will have different sessions, maybe more theoretical and more practical exercises, and Dacia will obviously expand much more on this. And these sessions will cover different parts, starting from the general project financing and going into banking procedure and how to prepare a business plan, or how to make sure that the project is actually bankable, what type of financing existing. So I'm not going into details of this, and I would give straightforward the floor to Dacia for saying more and how he is planning to have this role of this next 2 days. Thank you.
Thank you, Nadezhda. Chief Commissioner, I will switch off your presentation. And I'll. Now, colleagues, now we start the more informal part. First to introduce myself more detail. I'm Dacia. I am an engineer originally. I worked for more than 20 years building power plants and petrochemical facilities and things like that. And after that, I became a banker because without money, you can't build anything, I'm afraid. And so I worked at EBRD and after that at finance company. Now more or less retired, but still working. We still do some projects. So I have a view from both sides. The engineering part, the real project side, and the financial world. It's very difficult actually to talk and introduce these things to such an esteemed company, bankers and officials and consultants who anyway experienced. And I'm thinking how to start, what to say first. And I always start with bankability. It's a very popular term. It says when a project is bankable, when a project actually could be financed. Because not every good idea is unfortunately something finance. Even you, I know, look at that. When something is financeable, is it worth for you to put your money in? Are the banks going to finance it? So I'm trying to say, what is bankability generally? And no, okay. So I will not repeat because Sana, Oleg, Nadezhda they explained what we're going to do, and these small loans and so on, they will provide assistance in financing of energy efficiency and renewable projects. These projects, renewable, as far as I understand, will be small renewable projects in most probably photovoltaics and things like that. I don't think you will build concentrated solar power with small loans. So let's focus on small manageable projects. And I will not repeat that, but my colleagues already explained what is the aim of this. We actually, as a bank which provides money, CBRD is here, and one of the banks which will disburse loans to the clients is here. So I'm not going to repeat, but the aim is that their projects, because always we say, oh, there are no money in energy efficiency, renewables, and the bank say, we have the money, but there are no projects. So we'll try to match this. So we have you, with the assistance of this people here, to present to you projects which are bankable, projects which you can finance, and to accelerate this process so that the worst things, I worked on a number of credit lines, and some years was very difficult. You had, the bank provides, opens credit line, it's not disbursed. Very bad, you have to report in London and say, actually the disbursement is very low, there's no uptake of it. There are no projects, and we will try to avoid any such situation. I understand money in demand here, but we have to make that the projects which are financed, a projects which are worth. And now I'll make a small diversion. Because one of the first questions is why we bother with banks? Why we need banking money? If you have money to do a project, why don't do it itself? Why bother? Why bother to go to the bank? Fill all these forms, put some security, some assets to secure your loan, and pay the money back, pay the money with interest. Why we bother for that? That's a fundamental question, actually. And before continuing with the presentation, I'll just make a very simple calculation here. Can you see that? Yes. So I get a small project, 150,000, which are financed entirely by your own money. Everything is said. You finance it, the project works, you don't borrow money, mezzanine loan, senior loan, nothing. And it's your revenue from this project, it's a real project, I just data. And the banks, annual return, 20%. The overall return, so is the overall return on your equity, your capital, is 20%, which is good. With 20% internal rate of return, economic rate of return, it's a good part. So that's good. So we can do it. If we decide to go to a bank and borrow money, what will happen? Let's go downstairs, down legislative. And here, as an example of you borrow the same product, 150,000, same revenue, but you borrow money. And you borrow senior loan, so the loan is loan which you have to pay first. And they have first call in your security. So you borrow this 120,000 and you actually put a capital of only 30,000. What will it be? Yeah. Share screen. I don't know. Yes. Are they are? Yes. I said, what? That's fine. And so then you pay them loan. I said, this is money. And they go from your bank accounts. And what do you think? Is your return on equity, you put capital of only 30,000. But you pay loans. Money. But Obviously, because you put only 30,000. Now your return on your capital was 20%. Now it's 39, almost double this. Okay, yes, please.
Okay, continue and we'll try to fix it in the meantime.
That is the main point. To borrow money, but still on your investments practically doubles from 20%. And that is the point of leveraging your capital. Your capital works much harder. Much harder. Now you can do what if you have capital, 150,000, you can do actually 5 projects. So the risk on your capital is 5 times less. Because if one of the projects fails, still you lose only 1/5 of your capital. And the return on your capital is increasing, doubles. And that's the point of borrowing money.
But there is a condition. The bank,
Come to that. But I just want to illustrate how important is to have money which is cheaper than your cost of capital, obviously. And the length of the loan is less than the length of the period for which we calculate the internal rate of return, obviously. If the banking rates are more than 20%, it's not working to do that. But if they're less, which usually is the case, because you don't present projects with 1% IRR. Point. It's not worth it. But so that is the point of borrowing money. This is why the countries would develop banking system are wealthier. And this was not, it's not now. John Adams wrote about that, and Karl Marx wrote about that. That if you have a good banking system and you can leverage your capital, make your capital work much harder, this makes the country wealthier, makes you wealthier. Otherwise, you will spend only your money and your capital. And this organic growth is much slower than if you leverage your capital, distribute the risk among different partners, bank and you, and makes the project worthwhile. So this one is just a small diversion, just to show you how important is that. How important that if I provided to the couple when we explained how projects work, and if you borrow even mezzanine loans are usually much more expensive. They have inferior requirements to the senior lenders who provide a senior loan. And they take much more risk. So of course, the rates are much higher. I don't think we will have such case here because it's a very specific facility. But if you could leverage further with that loans, you will have even higher interest, internal rate of return of 60%. Because you invest only 10,000 in this case. You invest only 10. Your equity is only 10,000, and even paying these loans, you have much higher internal rate of return. So this is really straight. Why we talk about this? Why we borrow money? Because this will make our project work better, our capital work better, and you will be wealthier. So I hope the banks will give me a nice treat because I try to promote their business. So let's switch this off and continue with presentation. So, as we said, we're trying here to prepare projects, help trade, prepare projects which are bankable. To be bankable, it's a lot of things. A lot of things make factors which influence our approach. First, of course, is government support. If there is no government support, sorry, if the project is not supported or if it's against the laws, regulations, obviously the project is not bankable. I used to have a lot of students from Saudi Arabia at one point because of this Arab Spring, Saudi Arabia sent a lot of students abroad. So they came to our university and we discussed what makes a project profitable. And of course, for example, alcohol is usually very profitable. Not mention drugs, but it's very illegal. But alcohol, for example, is a quite profitable business. However, such a business is not possible in Saudi Arabia because it's illegal there. So, legality has to be legal. You have to have the government support in the sense that it's allowed that the regulatory base, laws and so on support this project. Not support, but doesn't at least prevent it. And next is, of course, is the market economics. In this case, because it's about energy, energy savings, you have to see there is a market for this. There is a market. The electricity in excess is very cheap. It's very difficult to achieve energy efficiency, obviously, because whatever you save doesn't bring you much cash. And you borrow cash. You should always remember, we're talking about money. Money, and you need whatever you do to ensure that you get back enough money to pay your loan and to get enough return. Otherwise, it's pointless. Pointless. You just waste your capital. You waste the country's capital, your capital, and everybody's time. So the market has to be there. If there is a market, comes the project. Project economics. Of course, the project has to be economical. Has to produce enough, provide and produce enough to justify its existence economically. We're not talking about financially, overall enough. And very important. Contracts. If the contracts, there is no structure, not established system. If there is a power purchase agreements and so on, if this system doesn't work, or worse thing, if the contracts are not enforceable, you may have the perfect contract, nicely written, 126 pages, and you can't enforce it. It's a pointless piece of paper. So that's very important that the contracts are there, it's a legal structure, and these contracts are enforceable. So if, for example, you save energy and you go and you have to be paid for that. And if you go to the electricity company, whoever, they say you have to pay that. And if you can't enforce this contract, this whole thing is pointless. Security package, I don't know what security is required for the loans. This is the bank's game, you can ask them questions, because I cannot answer that question, but Usually there is some, it's a risk, reward, and of course, you borrow money from the bank and you have to provide certain security, certain assets or money and so on, as in case that your project, your loan repayment doesn't work. You have to provide security, and this has to be, there has to be enforceable. And the last, but one of the most important thing is that project sponsor in this case is people who own the project. Not the project sponsors of the football club here across the street, but project sponsor in finance means the project, people who own the project, who provide the capital, who manage the project, who push it ahead. So they're called project sponsors. They have to be there. The worst thing is a project which doesn't have good people who could borrow this money, implement the project, support it, provide capital and so on. If you don't have that, and they're not committed to the project, it will fail. So don't bother with people who come say, yeah, all right, okay, we'll do that, but we're not sure. And they drop the project in the middle, you waste your time, the banks waste their time. So that's one of the most important. I'll put it first, honestly, but here is just there. So that's a critical thing. And I just provide, I don't know the system here, there's a number of issues, but what project makes it bankable? If you have high perceived risks are perceived, something which is risk for Lina there might not be risk for you, but it's called perceived risk. Because risks, depending on which side you look, they look different. So the perceived risk will have to see from the point of the bank. So represent the project of the bank. If the bank perceives this project in a high risk, it's no chance. And of course, it's here, and it's returns. If the returns are high, if the risks are high, they get better, they get greener. Because the risk-reward system always works. You may take higher risk, but you expect higher rewards. But still, there's a limit to that, obviously. So bankable projects, they should have lower perceived risk. High perceived risk is specific facilities like hedge funds play on that. Specific facilities were prepared to take high risk and high rewards. They expect returns, they risk their capital, but they expect returns of excess of 35–40% of it. So that's different, not in this case, but I mean, depending on the type of tariffs, for example, are they tendering the obligation to pay fiscal incentives or feed-in tariffs? The process could be put in different. I had this in different countries, but because I don't know how it's in Macedonia, I deleted these spots because I don't know what system is.
Two tariffs. Two ways. One is with feed-in tariffs and another is without feed-in tariffs.
Okay, all right. So this is the two ways,
Two models.
yeah.
Estonia.
Okay. So if the feed-in tariff is good, it will be here. If the feed-in tariff is not good, it will be somewhere here or here. So depending on the fiscal situation. And so government support, just to elaborate a bit more, is we have the framework. Because in many countries, and I don't know here in detail, many countries you don't have the institutional framework. You save energy on what? That's it. It's your business. You save energy, Fine, you save some money from that. Your bill might be a bit less, but that's it. You can't do more than that. And here is about the financial infrastructure. If there is a financial infrastructure, there is this facility, this still exists. It allows investments and energy efficiency renewable projects. Yes, yeah, please, thank you.
The main problem in our country is secondary infrastructure.
Secondary infrastructure.
They haven't enough transformers and they haven't enough electricity network
to
have response that are bankable and very good for solar, for example. This is a main problem.
It's not this is indeed financial infrastructure. Financial infrastructure, the facility is here. So this is big green thing. I will talk about engineering infrastructure later. This is a problem not only in Macedonia. This is a problem all over the world. The problem in the United Kingdom. It's a huge problem. They introduce projects and they have to curtail them after that because the electricity, as in UK, Germany, and so on, getting more and more expensive because you need to build more infrastructure and that's very expensive. In the UK, they estimated that this infrastructure would be around £5 trillion. £5 trillion to upgrade the network, the grid. So, yes, I fully appreciate that, but this we're talking about finance now. So finance, yes, is there. European Union, and government, and EBRD, and so on, they support this thing. And one of the most important things for the government side is that you need a very clear legal regime to enforce the contracts. Because otherwise, it works. So you need a judicial legal system which enforces contracts, land ownership, taxation, everything. Because I have seen, unfortunately, projects which are good, promising, and the governments get greedy. When they see something works, they try to make some money because their budget's always in deficit. So they impose new taxes, new regulations, and so on to get some money from these successful projects. So we have to be aware of that. I don't think for such small projects this will be the case. But for big projects, yeah. I have unfortunately seen this in some countries. Successful projects, very good. It's like a magnet for the governments. You can say, okay, all right, we can tax them again. It's more and make some money out of that. It's again a bit more for market economics and well, of course there is significant potential for energy efficiency in businesses, industry, buildings and so on. So there is no risk to that. Energy efficiency is always something which pays on the tax. And the potential for renewable energy will look later on that. There is potential for renewable energy. As far as I understand, I don't think you are going to finance wind and things. Probably this will be limited to solar heating, solar PV, photovoltaics. But there is a potential in Macedonia for that. And everything, of course, depends on the tariffs for electricity. So we pass say, but they still, even on solar, there are a few projects in Macedonia already operating, bigger one. But the question is so much to do with the small projects. I traveled through Macedonia yesterday. Very unfortunate because the panels are covered with snow. So the return on the investment at the moment is zero. Yeah, covered with zero. That from Kriva Palanka to Kumano was on there, some stations, but they covered. That's now. There are some risks of the project. And energy efficiency project, of course, the supporting industry is not only the government, the market. We have to have the equipment, we have to have the specialists. If there is a limited number of that, of course, this limits the market for energy efficiency, for example. And so here, the limited installed capacity indicates, and I hope that facilities like that, yeah, the previous facilities, it's not the first one, they will provide support and accelerate the implementation of energy efficiency projects. Project economics. Now, for energy efficiency, very often we tend to exaggerate what is the actual savings. One example was one of the ministers around 10 years ago decided in the UK to check actually, because the government provides a lot of support, insulation, homes and things. And they decided to check what's the actual saving, because they provide you the grants, they insulate your lot. Wow, that's very good. Makes the house warmer. And the industry claimed that you save 20% minimum. You put insulation and it's 20% savings of energy. The minister he was being an engineer, he got a bit skeptical probably and said, look, let's check that. Go to the consultants, go and check. What was the saving, you think? 1.7%. So less than 2% savings of energy. But they claimed the minimum 20%. So government said, stop this. It's a waste of public funds. So you have to be careful, actually, what is claimed and what the reality is. And it's very important that the feasibility study is realistic, well prepared, and so on, to say yes, this will achieve this. Or very often we talk of small projects, people borrow money in IT, which says on the nameplate, it provides savings of comparison to previous equipment of so many percent. And then you have some warranty, because if these savings are not achieved, you can claim back, go back to the producer of equipment and say, look, we couldn't achieve that, you pay us compensation. Because it's a warranty. They guarantee that you will achieve this saving. Solar projects, for example, I've seen here in Macedonia, projects they claim like they in Sahara or southern Spain, that they will generate, not to mention, 2,000 kilowatt hours per kilowatt installed. Obviously impossible. And you have to take a realistic view of that. When we do big projects with the banks doesn't rely on wind, is very particularly difficult. Doesn't rely on one feasibility study. They have their own company, which they say, we'll go and check now. The probability of 90% is called, which means that the probability in 90% of the time that the actual generation of this power plant will exceed whatever it says on your estimate. 90% of the time. Some banks even go to 95%. So they assume that very conservative, very down assessment what this project will generate. They want to be on the safe side rather than optimistic side. Because as an investor, you try to capital owner of the project, but to present the most, believe in the most optimistic case. Everything will perfectly, it will generate all the time, no snow will fall, but the banks risk somebody else's money. Money even not in the bank, somebody else's money. So they risk the money to finance the project. They have to be sure that the project will generate enough value, enough cash to pay. So, very conservative. And cost, money. If the project, how they push, we have to save carbon dioxide, and suddenly in 2050, all the houses, 2035, all houses will stop using gas. For heating, we'll use only air heat pumps. It's like air conditioning, but in reverse, and this will be perfect. That's fine, that's fine. But the cost of equipment is prohibitive. If I decide to do my house, the system will cost around £60,000 to lay pipes and so on, change everything inside, because it's a low density heat. So the pipes for the heating, I have to increase them. If now they're ½ inch, I have to do them inch. But like that, so to lay all the system for heating, all the radiators, they have to be 2 or 3 times bigger. I have to pay £60,000. Now, the money now are the most expensive, as we later on, and I have to pay that. And when I'll get my return back? And short tours, never. Especially my age, to get that. So we have to look at that. If the cost is too high and doesn't justify it. What's the tariff for electricity now?
3-4 dinars
3-4 dollars
per kilowatt.
kilowatt. So it's 5 cents, 5 euro cents.
But both.
It's households, yes.
Yeah.
And gas, because you mentioned the example, can we make it in financial to see the trends of the prices of gas and the trend of the prices of electricity, so we can compare? And let's not talk about reconstruction, let's talk about a new build project.
Yeah.
And then we will get maybe a realistic result of the, if we have an example of trend of prices of gas and electricity, and what are the trends of renewables. If the renewables are increasing, the production of electric energy from renewables, and the gas. So maybe we can say for 10-15 years what we can estimate what the price, then we'll get, besides, the air pollution, besides all these consequences from the conventional way of heating.
Yes, so we've done for EBRD projects to convert the electricity system of Uzbekistan on renewables entirely on behalf of the World Bank and EBRD. It's a big project. It took us 2 stages, more than 2 years to do it. And the results, colleagues, are very, how to say, difficult to swallow. Yes, the electricity gets more expensive. Very simple reason. You rely on very low density source. Very low density. with solar and wind. Uzbekistan, as Nadezhda will confirm, is a landlocked country, so there are no seas, double, one of the few countries double landlocked. And so there are no seas to provide wind and so on. And the wind has a relatively low
Production.
Yes. And solar is good. Solar is good, but it's also very low density source. The worst thing is what you do at night. What you do in the winter. Uzbekistan is a relatively warm country, but in the winter it gets cold as well. And the demand then for heating and so on is high. We have to replace the heat. We have to replace the coal from the industry, steel making. We have to replace transport. And you calculate, look at the trends of growing the demand. The demand in per capita in Uzbekistan is relatively low. Relatively low, and they want to catch up. They want to live more better lives. And when you calculate everything, it appears that yes, you can do it, but you need old batteries, which does not exist in such many thousands of gigawatt batteries to keep the system going on at night. And not only at night, but when there is no wind and no solar, some gloomy day in November, outside, no wind and not much sun, and they don't exist physically. Another thing is to build gas power plants. They have still some gas, and these gas power plants have to, thank you, they have to work when you have to capture the carbon dioxide. Is there such technology? Only experimental. So for now, to be frank, that's a pipe dream. It's a dream. And we have to strive, however, to do the best we can to deliver something which works and something which is economical. Because the simple facts, you don't need to be energy specialist, system operator, and so on. You can see why the electricity in the world is the most expensive. In the country which implemented the largest energy event in Germany, but the most expensive electricity. They put a lot of renewable and the electricity price of electricity goes up, not down as they promised us. So you have to be careful to what extent we can go. Bulgaria, small country. Now there are applications there for the system. At peak probably uses around 3,000, 4,000 megawatts peak power. And maybe it goes to 6, to be fair. But in the summer it goes to 3,000 because, of course, it's nice and warm. You don't need much electricity to heat. And they have applications at the moment for more than 15,000 megawatts of solar and wind. If they build that, A, the country will be bankrupt, and B, the system will be broken because you can't manage 15,000 pounds in a 6,000 system, 15,000 additional renewable capacity into the system. And the electricity will get what? Very, very expensive. So we have to be careful of to what extent we try to implement that. So this is the version starting to do that, but you have a very good question. Very good question. Very good question. But now for the situation which is in Macedonia, implementation of small solar and so on, that's a good idea because it saves energy. They'll not consume a lot of, for example, electricity at daytime when they have nice sunshine. That's good. So it saves. But when you reach the point when this starts to disbalance the system, that's a good. When you reach this point, you will just making the electricity more expensive. Because you're obliged to buy from solar. Isn't it? This obligation to buy the generated from. Yeah, you're obliged to buy the electricity from solar. No, the market. The market.
Depending how we are. Depending of your business model. You can be on open market and sell on the open market, you can put the solar for your own purpose. And prosumer model. And the supplies to sell to the distribution company, it is several different models.
You can be prosumer or you can be on the open market level. So you're tied with the price of the stock exchange.
Yes.
And we have coupons as reference.
The pool.
Yeah. And if you're prosumer, then it's different. Then surplus is
so
the three and then just the balance with the electricity.
They also take in consideration that for different region it is settled down the maximum amount of renewables which can be put in place.
Yes. Yes.
Just in order to balance
the grid, yes, that's the point here. So I have a limit to. So I have to, this is like the project economics. If they say, sorry, like in India, they had even there is dispatchable. If they don't, if the system doesn't need it, they say, thank you very much, but I have wind now. We don't need it, goodbye. So similar to that we have, so this is.
Solar here.
Same with solar, yeah. They generate a time when nobody needs it.
You have, let's say, 3 o'clock in the evening.
Evening, you don't have it in the day at 12 o'clock, you have a lot, but nobody needs it.
Can you explain something, some specific here in Macedonia? In the last 2-3 years, we invest many projects in solar energy. Very big, small, big.
Yeah.
It was expansion.
Yes. Yes.
And now the electricity expert engineers, they talk, they it will be good if we invest in hydropower.
Yes.
Chevron, and this will balance how it works.
How it works? Okay, all right.
How?
It's a pleasure because I'm an engineer. I built one hydropower storage. It's called
Tells that we are.
Yes, yeah, all right, no, the pleasure. I had some participation in the project around 40 years ago, more than 40 years ago, and a project which was called Chair. It's a hydro pumping storage in Bulgaria. And they succeeded last year to break one of the turbines. Anyway. Some, yes, incompetent, they hired not Toshiba, which provided the equipment, but hired somebody else because it's cheaper. And they have to repair it. And they opened the switches and the whole pressure water hit the turbine and broke it. Now they have to replace it. Nobody knows how. It's underground. Deep underground tunnels. So there are 2 hydropower plants, 2 dams, reservoirs, like that. And when it's daytime, at night, that's the fact. No solar, nothing there. So you need electricity. And the reservoir provides the water down, generates electricity, provides in the grid. It's clear, hydropower plant. At daytime, excessive solar. Nobody needs it at 12 o'clock or 1 o'clock.
It's only works for the reversible.
Daytime. Generator here. And the turbine became a pump.
Yes.
This pump pumps the water up in the upper reservoir for the night. And EBRD, my finance, this then finance, physically I participate in this, but in EBRD finance, it's the same hydropower plant, Zagorsk in Russia. Something years ago, Zagorsk power plant, hydro storage, 2 reservoirs, and the pumps are huge. Enormous turbines, so you pump the water back. The efficiency of storage, because you have losses, obviously, evaporation, and mechanical loss of the turbines is actually quite high. It's around 75%. 75% loss, but 75%, which is very high efficiency. Of course, the lithium batteries, they have 97% efficiency, but you can't store this. And one of the things is that the lithium batteries doesn't have inertia. In the moment it stops. These systems, they have inertia. The generators, it's a big rotating mass which keeps for few seconds the energy flowing, because you need to keep the frequency in the system 50 hertz. And this power plants, they have inertia. The batteries don't have inertia, and this is a big problem. You have maybe in future electricity stored, but there is no inertia, which is creates a big problem. It's not, it stocks the energy with nothing. Well, here it will gradually go down. So the system management is a very, very, very complicated matter. But hydro storage, if you can do it in Macedonia, and you have 5, we financed with EBRD hydropower plant here behind these mountains here in Skopje. Matka. Yes. So that's if you can do that, it's extremely important. Yes.
Just to clarify, this project is not focused on hydro at all.
No.
Previous projects are focused on small hydropower plant. But for this particular project, hydro and wind energy is not eligible. And also I like to share with you the solar energy is somehow estimated on 30% of our facility as a maximum support for from the grid solar power production.
Okay.
That is because of the reason the main focus are supporting small and medium-sized enterprises, and big hydro is something.
No.
I just want to.
Thank you. I know that this is a question. Big hydro storage schemes, they cost.
They will construct this. Yes,
have to.
In general. It will be the case.
And this is a question and answer. Obviously, this is not eligible. Unfortunately, yes. But under this facility, it's only small and medium enterprises, energy.
Me personally, I'm also engineer and I'm fan of hydro, but.
There you are. But there are other direct loans provided, so I hope the government of Macedonia do that. And one thing which we'll discuss in detail is that it's not only return on equity, the capital, but is the debt service coverage ratio. The banks have to be satisfied that you get enough money to service your loan, service that. I will discuss this. This is the core of the training. And the contractor, I will not go to, because the contracts, of course, they have to sign one of the contracts possible. I'll not go into detail of that. There will be some projects, but contracts are very important. Have to be well prepared. You buy equipment, you need to have all the warranties, you need to have all guarantees, you have all the insurances, which the banks, of course, will insist on. Because if something happens, they have to be sure that somebody pays. Very often we have this idea, oh, this was force majeure. Yes, force majeure, but somebody has to pay. But don't forget that.
It's not freelance.
Might be force majeure, but you have to have, never freelance. You have to be sure that the contract provides sufficient cover in all circumstances. And force majeure, there is, you do not apportion blame that is your fault, but you have to have a provision in the contract that somebody pays. Something happens, somebody pays, somebody covers it. Or insurances, whatever, you have to have that. I really hate when they say, oh, it's a force majeure. And what? Somebody has to pay it. And we had a TPRD turbine, it's my project, and it had to be delivered to Belarus. And suddenly there was these floods in Poland. And bridges were taken away, and now all the roads were flooded, and the turbine got stuck. Can't transport it because it's heavy. It's very heavy, it's a big thing. And it got stuck in Poland, in muddy roads in the middle of nowhere. And it caused few months delay of the project. And each delay, each day delay, is cost a lot of money. I've lost generation, and of course the contracts, the project contracts were well prepared and so on. And we had a provision who pays for this delay. Otherwise, the contractor will be bankrupt because if you get paid for 6 months delay, you will spend a lot of money on that. So you have to really clear, really good contracts. I don't know for such small projects, but still at least you need the warranties, the guarantees, the performance and so on, all the guarantees, all the warranties have to be there, and provisions that who pays for what? The contractor, the supplier of equipment, and the producer of equipment. It has to be clarified, it has to be clear in the contract, and you have to have the provisions for that. Because otherwise the project is not bankrupt. You don't have a provision who pays something doesn't deliver. For example, you buy equipment, they promise that it will save 20% energy, for example, in comparable thing, and it doesn't. You promise to produce 10,000 cups, for example, a day, but it can manage only 6,000. Who pays for that? It is underperformance. Whoever installed the equipment, or whoever produced the equipment, and it has to be clear that you have this provision and it pays. So the money come there, and the owner of the project can service the debt of the bank. Because that's the most important thing. You have to service your debt. You borrow money because it's good for you, you make high returns, you share the risk with the bank, but you have to be always able to pay. With not only enough money, but with a cushion, reserve, that always you can service your debt. This is security. I don't know what security is. Security, not the security as the guys outside. but the security is in the banking terms, it's you call that, is the assets or collateral you provide to the bank in case of the non-performing loan. And there are a lot of issues, of course. You have to be aware that the bank never assume completion risk. Completion risk, never. They may assume other risks, political and so on and so on, but never completion risk. Completion risk is entirely the project owner risk. Through contractors, and suppliers and so on, they never do that. So they will ask in the contract to have sufficient provisions for non-performance, for damages, and so on. This has to be clear. Banks don't say that. And also one, I don't know here, but can you use these contracts to be used as a security? For example, that you have a contract, performance guarantee contract, a warranty contract, and this provides a security to the bank. Ultimately, that the project owner will get paid and you can accept this as security. That if something happens to the equipment, it's this provision in the contract covers part of your security. It's really allowed to do that. Yeah, if this is more for big projects, but to use export credits guarantees, if you buy equipment, for example, from Germany, you can go to Hermes and say, look, we need the contractor, we need export credit guarantees for this project. But here we're talking about small projects. I don't think this will go to export credit agencies, but just to mention it. Yes.
When we discussed with you this training, we mentioned that maybe our not primary objective, but secondary objective is to present, because investing in renewable energy and energy efficiency is quite, how to define this, advanced and
yes,
it's new products.
It's a new
product for the banks, you know. And you talk about provision and not proper repayment of the loan.
Yes.
Collateralizing. One of our secondary objective is to try to present to the borrowers that the project by themselves should be self-sustainable and to repay the loan. Which is not only the energy saving, like a saving, but also improving their
financially, it has to be sustainable. If it's not bankable. Absolutely.
It is in line what we talked previously, that
Absolutely.
good and feasible feasibility study.
Yes. If the project doesn't deliver returns, cash flow to the owner and to enable to service that, it's not worth doing it. And you're absolutely right. That's the main point. I'll look later on the models now, but which is exactly this the point. If it's not worth doing it. It's just waste time and they invest money. Absolutely. Equity. I don't know the situation of equity, but usually the banks require some participation in the capital in financing the project. Otherwise, there is no commitment on side of the owner of the project, because if you don't commit any money, you can just walk at any time and say goodbye. I bought this project. It takes too much of my time. So you need financial commitment. Financial commitment is not only direct money, because here, if you remember, I showed that 30,000, 50,000. No, very often banks accept so-called in-kind equity. This is in-kind equity is participation in the financing of the projects, land and equipment and buildings existing, which you provide as a contribution to the project. You evaluate the value of that as equity, as project, and we count this as a financial contribution to the project as equity. It's called in kind. And banking terms, in kind contribution. So, but that's a very important. You need certain, it depends on the project. So the project in which you look at them when you do the models, how much capital you need to put in the project to make it back. But usually you need to put some capital, otherwise the bank will take all the risk and you'll just get only the rewards. It never works like that. So that's important. I don't know the levels of that, but in the model, we'll look at the adequate levels of which provides enough money, cash to service your loan. That's the most important thing for the banks. For you, is that the price you return. Put some money and you expect that you get some return. The other side of the equation, the banks expect that you service your debt, no matter what, you service your debt. Otherwise, default, and nobody wants defaults. Nor you as a home, or not the bank, because I've seen banks who has to manage coal power plants. Because company cannot service the loan, the banks became the owner of coal power plants. What you do? Bankers going to think coal? That's not the nice thing. So nobody wants defaults, so we have all the contracts, everything is structured in a way to avoid such a situation. As I said, a lot of uncertainties. And actually, this is how the banks value their loans. I mean, they establish their interest rates and so on uncertainty. It's as uncertain is the project. And returns, as high is the risk. As high is the risk, the bank would expect higher return, higher profit, because it's a risk and return, and will make the project. This is, we have to try to reduce the uncertainties, make it clear. It might be not the best situation, but at least you know it. So you can make a provision, make calculate it, and know what to do. But uncertainty is really bad, because you don't know. Is it good? Is it bad? And then you assume that is the worst. So when you prepare a business plan, when you evaluate the project, uncertainty has to be as little as possible. It is more or less certain. Of course, it's God's will. Solar, like shine may not, but at least you have to reduce the uncertainty. You assume probability that this thing happens to a minimum and make everything as certain as possible. Then the project is back. And risks. Now I say risks are mitigated. Colleagues, risk only exists. You can't. It's a risk. You may transfer it to somebody else. You may cover it through insurances and so on. But the risk, that's a fallacy of 2000 crisis, that the risk suddenly disappeared. No, no matter what you do, risk is a risk. This is something which may happen or will happen. But we try to prepare ourselves for a situation through contracts, through insurances, through technical measures against earthquakes, against, I don't know, snow. We can't stop the snow, but at least you may envisage that somebody goes there and cleans the panels. I don't know, for example. So the risk exists, and we have to make provisions to manage that. But don't risk. Only the people who doesn't do anything don't take any risk. But we do something, so we take risk. So the risk, they do exist, but we have to manage. And this is what makes a project bank. And what the banks face here, I'm talking about your registration book. If you have a complicated regime, uncertainty, unclear legal regime, how do the projects? Position of local population. It happens. You want to put solar panels in a. And the people say, yeah, no, it makes it's not nice here. Yeah, of course, I know that. Yeah. So we have to, we have to think about that. Contractual issues, as I mentioned, complex implementation. And the worst thing which we try to help here is inexperienced developers. They have to understand how to present something, not to waste the times of banks there. And when you have incomplete proposal, of course, it's time and efforts for the banks, and they say, oh, we get that. And you have not enough applications and have which are not. So we try to help with. Okay, so to have a project bankable, you need all these things sorted out. If you don't have non-bankable projects, waste of resources. Okay, what's the time now, Maria?
It's 11:06, so if you're ready for a break, we can.
Yes, probably. They have enough. Okay, thank you for listening and thanks for your questions. I say that. So you have to work, and that's the way to.
So we're ready for a short break. Some snacks will be served. Thanks. In this area, please feel free to thank you. We'll be back in 15 minutes, 20 minutes.
Money there, 12 months, 12 periods, learn something. So the effective rate is effective rate. From point of view of the bank, 7.3%. Yes. This is the formula. And then what's the prevailing rate now of the banks? 7.
You're close.
6.1% is the base rate I checked. Out of the National Bank of Macedonia, so I'm trying to be around there.
Okay.
So that's it. So
It depends from.
inflation. How do you calculate? Inflation. The simplest thing, of course, if you have inflation rate 0.5%, that's not realistic. It is something. No, that's
It sounds funny.
That's the 7%, to be more realistic. And the inflation rate is?
Inflation? Against around 2.
3. No, I checked. I checked. 7. Now they say it's a 3 point something percent.
Now?
Yes.
Till the end of the year, 1 point something.
Official.
It's actually official. So this is 3.5%. That's
5.7.
Really, we have inflation?
5.7. So, now, of course, the simplest thing is to just 7% take out 3.57. But because if we want to be precise, your banks work a lot of money, and this is your capital. You borrow money, you want to see what actually, the actual rate. Your capital, how much? So that's it. This is the formula. This is the formula here. This, I'll provide you this, is provided in the document. So don't worry about, don't write it down. It's not a secret formula, but this is how we calculate it. The simplest, of course, the simplest way is 7 minus 357 will give you the result, but it's a very slight difference because it's difficult to calculate. I'll put 3.50. And so to see, instead of 3.5, the effective actual, the real rate is 3.38. It doesn't look much, but of course, it's many. So this is the precise formula calculation of the effect on inflation from the inflation on the nominal interest rate. So if you borrow money at 7 and inflation is 7% perfectly, actually you borrow free of but if your project generates that, otherwise, I'm afraid not. Okay. This is similar. This is this is most applicable if you go there and borrow money. For example, if you each period for 12 months, the annual rate is 7%, but the monthly rate is 0.57. It's a difference. This is the formula calculation, compounded interest, obviously. Yeah, so you have 7%. So it's interesting because sometimes do you have this pay loan, or you go down high street and these companies, you can borrow money and they say you pay only 1% a month. Nothing, 1%. And actually that's quite a lot of money. Because 1% here means more than 12% a year. So very be careful. 1% or 2%. You pay only 2%.
Approximately cost of factoring in Macedonia.
Oh, yes, factoring. That's factoring. Yes, that's factoring. Exactly. It's factoring. Yeah. So the formula is here. Read it. It's here. And you can. If you have any interest, please ask me. Here is a loan amount of £100 at the rate of, let's put 7% here. More realistic. And 12 months, this interest rate of 7%. 7% is the annual rate. For 12 years, you'll pay 225. That's
Nie meseci godini.
No, it's a godin.
Jeszcze nam 10 godzin.
Annual interest rate is always hard. Annual interest, it's not monthly. So you borrow money, what is the maximum 10 years? 10 years, it's 10 years. You borrow £100 with 7% interest rate. In 10 years, you have to pay almost £200. So to be clear, not to be surprised. For compounded interest rate. Now from there, of course, here bankers, I don't want to go into details of this, but just to, of course, from a point of view of the investor, of the capital investor, people who put the capital in the project, the equity, we have to know that future money are less valuable than the money today. Most valuable money at today's match. Better bird in the hand than two in the bush, okay? And the most valuable money at today. Future money, they have less value because of things like risks. like inflation. And so obviously less valuable. And different projects. If I'm a project and CIMA is a project, we have different discount rate. I'm much older. Only 20 years, their value is zero. That's the problem with that. But if he's young, his discount rate is less. And so
I wanted to say I'm stable.
you're stable. You're stable. Yes. So and let's say you have this is a compounded interest on deposit, and which we calculated, and we have here the discounted future money. Discount rate. Let's put here that the discount rate is discount rate is 2.5 is too little. Usually we use something like 10%. Yes. So if we have 100 pounds, 100 pounds today, in 10 years' time, 10% discounting, devaluation, lessening the value of the money, they'll be worth only 32 pounds in 10 years' time. 100 pounds today. The value 100 pounds in 10 years' time. Somebody says, I'll give you 100 pounds in 10 years' time. From today's perspective, their value is only 32. That's the discounting. The future money are much less valuable. And here I think in this sheet I think here, huh? Yeah, I have calculated this 2014, but this is the inflation rates. If we take as inflation from 1751, the Britain inflation was 2.70% inflation. See, and this is in 1751. These are the Turks here. Yes. So yeah. Anyway, but they had banking then, and you can see what's the inflation rate in 1809, and you can so on and so on, and you can calculate with this with the average calculation and see what's the present value of money in here. For example, your grandfather invested 100 pounds in 1888. My grandfather was 88, 100 pounds in 1888 because my father. Okay. Yeah, we can see what's the value today. That it's a formula, it's a rate, so you can see what is the value. Now, more to the point here. Now, I call it mortgage, but this is the equal repayment of loans. Equal repayment of loans. Mortgage is a payment. Mortgage is when you borrow money. What's important? When you borrow money to buy a house, you pay every month, and you can see how the payments go, and you can calculate the remaining part of your mortgage loan at any point, and the formula is provided here. It's the balance of the loan in year 25, Year 5, you have 80, you borrowed 100,000. In year 5, you have 89,000 still owing to the bank. Not very much. And I'll tell you why is that. This is the formula to calculate equal repayment loan, which probably you'll use equal repayments. You'll not use amortizing loans, the bank.
It depends on the bank. It depends.
You're asking the bankers. They pay equal repayments?
Yes, most of the banks.
Every month or every month? So that's the case. Okay. That's this. I'll show you after that a big project of finance on different way. Usually you pay there on amortizing loan, or you pay equal portions of the
Capital.
principal of the loan. Yes, and amortizing interest rate, but usually small loans are paid this way, this equal repayment of the loan. And here we have, for example, mortgage payments. For example, here, if we have 100,000, we borrow at 6% for 25 years. And the month will be 300 pounds, obviously. You pay every month 644. This is the formula to calculate equal repayments of the loan. So if you borrow, so you can give me some numbers if you want, and we'll calculate that. We'll put again the interest rate at 7%. Number of periods, 10 years.
7% is.
No, why? 10 years loan will be coming from 20 months. And each month you have to pay 1,161. Why not?
Yeah, but the physical installment will be 1,000. The practice, it's a installment of the total repayment.
This is the top. This is the most
hypothetical.
It's the month that this is how we calculate. Shares. I put 7% now. 7%. 10 years. 120 months. Each month you pay 1,106. Okay. This is at least what the formulas.
Yes.
Now, one specific thing here, which I want to illustrate, is how the payments go. You pay here each month. The blue is the capital, is the body of the loan. The principal is called. The principal of the loan is what you pay. And the red one is the interest rates. And you'll notice it's not like that. Logical. No, the banks first prefer to get interest loan. Why? Because this is their profit. The banks buy money on the money market, so get them for maybe a D in this case, and they have to pay this back. So this rate on which they borrow from the market of Euribor, maybe in Denmark in Mibor. And the margin which actually the banks make is on top of it. The total is 7%, but the bank doesn't make 7% profits. You have to be clear. So they prefer, and of course they make that first, they get the interest payments. Because this is there, and the risk is there. And of course, after that, the payments of the principal of the loan, increase and less. You should know that, not that the clients need to know that or they care about that, because at the end, what the client care is what what they pay every month, which is. If you want to see how much the banks will make, of course, it's a calculation there. Yeah. So they borrowed 100,000 and interest rate at the end will be 240. The total payment will be 240,000. 80,000, which is fine. Yeah. 25 years, so, or 10 years in this case. Okay. So this is the formula just to know that provided to you if you need to calculate or give. Each bank usually provides this mortgage or loan calculators, but just to have it in your pocket. This is the payday loan, you see. Is the credit cards, however, I just with curiosity if you need them. This is a self-amortizing loan. In this self-amortizing loans, this is it's not equal repayment. No. Sometimes for big projects, usually we use that. Use that, then you pay for this 10 years here. You pay the equal portions of your borrowed money, equal portions, divided on 10 or 11, whatever. And you pay the interest rate on the remaining part of the loan. And because you pay every year, the remaining part of the loan is lower. And lower, of course, the interest you pay is lower. This is a bit more beneficial, but it's difficult because at the beginning, of course, you have, when the project is working still, until you manage, you have to pay the highest payments to the bank. So this is only implemented for big projects, special project finance and so on, is paid on this self-amortizing loan. Just to let you know that this exists, and if you have practice like that, the bank you may agree. Very often, because the first payments are quite high, we sculpt the debt. You make the payments sculpted as you should do it, and so it can fit whatever revenues you have. So you sculpt the debt to match the revenues you have from the project. But that's advanced techniques, but in the advanced models which are provided, this technique exists. You can sculpt that. I don't think this is here, but yeah, we do. And also, I haven't mentioned, but you can hear, because of course, a loan is not only interest rate and period, but you have also grace periods and so on. Yes, you can put grace periods, which means that you don't start paying from the first day, because usually you need some time to work, you borrow the money, you pay interest during construction. Because until you work, it doesn't generate anything.
Sure. Oh.
On the first 3 years, you pay only the interest rate here. It's a great period, you don't pay for 4 years. And after that, of course, you pay higher loan. Higher payments, obviously, because of the shorter period. If we get a look at that. No, it's another payment which we very often mention. This is interest only. They say, look, we're not going to pay the principle of the law. We'll pay only the interest because the bank's interested in the interest. They don't care for anything else. So you pay interest on the full amount of the loan. And in the last period, when the year 10, in this case, you repay everything. So this is called bonds. Bonds. Bond payments and payments. Issue bonds. And you promise to the investors, to the bonds, some return. Coupon. And this coupon in this case is 5%, or we can put 7%.
That's those models in your country, Bulgaria.
Bulgaria bonds, yes, not for issuance.
So for what is it? Yeah.
Sometimes yes, but no, but I live in the UK. And I work there and I teach there, so it does.
The bank is applicable to Bulgaria.
So for advertising is for big projects, for finance, not for small project finance.
Yes.
And the payments of the loans are usually on 3 or 6 months, not every month. It's usually 3 or 6 months, quarter. But for the purposes of this side, I do it monthly.
For the raising the towers in Bulgaria, the company are paying the interest rate or not?
They pay it. But we can negotiate with the.
There is possibility to not pay.
To negotiate that interest rate start.
Not because in our country, the banks are the most profitable institution.
Depends.
In Macedonia, like.
If you're a good bank, if you're.
Every more or less.
So they have to pay for that.
Because they don't use risk project and these models, they don't use models like this.
Sure. So that's called, it's called bonds issued widely. They use it for financing of renewable projects. Green bonds extremely popular now. You deal every day with green bonds. Green bonds, EBRD issues green bonds here. And they are financing green projects or whatever. Green agriculture or whatever. But the green bonds are financing green projects, including efficiency. They're borrowed by big sponsors or governments. That's issue. Macedonia has a big bond as well. And they borrow this money and they promise a coupon. We can check on the internet what's the coupon promised by the government here.
More than 6.
Yeah. It is more than 6%, obviously. And let me see where the repayment account somewhere. It's here.
6.8.
6.8%. And very good, I said 7%, so very close to the point. So this is how the payments go. This is a coupon payment. And the last thing, you pay everything. This is in theory. In practice, they issue new bonds, pay old one.
Yeah.
But in theory, this is how it works. It's a green paper. This is the bond. I have to say the official line. Official line is you pay it in that. In reality, the government just borrow, put the borrowing and borrow again.
Our government.
Not totally, everybody. But the biggest, you know what is the debt of the United States? The national
overcome the trillion.
So don't say Macedonia. Macedonia is first.
Overcome the.
In that comparison, Macedonia is.
Of GDP.
Yes, yeah.
Oh.
So don't complain. Macedonia is in a very good place.
Very worse. Only the vojna će napraviti to.
So this is how bonds work. I have to say that because I don't think this is applicable. This facility, of course, is not, but you should know that. If you're interested, I can tell you how the bonds are valued and so on, but this is when you alone, I can explain why the bonds go up and down. For example, some of the bonds, they say the yield of the bond originally, when it's established, was 6%, 6.8%. Now, when it's traded, it got traded 12%, 15%. When the bond is, and the investors are not comfortable with this, I'll sell this. I'll sell it at a loss. I bought 1,000 pounds worth of the bonds, but I can sell it for 800, just to get rid of it. Then, of course, the yield of the bond goes up because you get the coupon, the same coupon, but didn't pay 1,000, you pay 800. Obviously, the yield for you as secondary buyer goes up. But if you're Germany and they trust your economy, they issue the bond, and they said the bond, the yield is 3%. People are paying more to park their money in a secure place, and instead of 1,000, they're prepared to pay 1,200. Then, of course, the yield, instead of 3%, which the government of Germany promised, will go to 2%. So the yield goes down. Yield down means that your bond is performing very well. Yield going up means that your bond is secure, is weak. There's a lot of financing by bonds, and this is what I wanted to say. Any questions on that, please? Because we're here, formulas, if you want to calculate it, to be fair, for example, I don't calculate such a complicated formula. For example, if I have to calculate the monthly interest, I just divide the interest rate on 12 and that's it, to be fair. But the formula is there, you can precisely calculate to the last, because the difference is very small. Such interest. If the interest is 30%, 40%, of course it will make more, but 7% is probably very minor difference, so you can, all right, 7%, that month will be half, 0.6, that's it. Okay, colleagues, almost there, you have it, you get it. Colleague Nadezhda will put it on website, so we have the formulas, the official formulas, nothing secret in that. But this is to make it comfortable to you, the people you are training, you're helping with the projects, explain that this is not a mystery. This is a very simple arithmetic calculations, so they should know that it has to be transparent.
In regular payments, if you want to calculate quickly.
Yes.
The actual interest rate, you will what you're going to pay. Let's say if it's 10%, yeah, you only need to divide the machine. Multiply it by 0.556.
Yes, yeah.
You will receive the amount.
Yes. You have to pay. But we have to show that everything is calculated on precise formulas for quick. But for quick, yes. Very often we don't calculate, as you'll see now when you do the projects, we don't calculate, you say, simple repayments, look at that. Well, simple repayments is 20 years, 10 years. It's not bad. Here. For 100,000, for example, 10 years, and if every year you get 10,000 revenue, obviously it's not. First doesn't work. It's obvious. But if it's 3 years, you start investigating further. Can it pay? What is the debt service coverage ratios and so on? So we have a quick. But you are right. Thank you for that. Yes. Until what time we have to? Lectures because
1 o'clock.
the next.
This is time preparation and answers.
Now, yes, please. The nice soft teams.
Very big.
Alex, I provided you, apart from this, thing, all this explanation.
Работа по издеймен обект.
I don't want to.
Да, лично нещо.
I provided a description of these things as well, so you can use this. Yeah. Discount factor and so on. This is just a few examples. Of the discount rates are not applicable to your projects, but just to let you know that seeking money, sometimes they discount 100% because the probability of loss is 100%. Mature companies usually the discount rate is 10% to 25%. Because depending on the cost of capital and depending on the risks and inflation. So all these things are together, and the discount factor is this the form of the discount factor. And I provided these things just to show you that these things are provided here. Here, the formulas for calculation of interest rates, loan repayments, and so on is also provided here. So they provide, and you'll get this all on the website, and I'll give you things just to show you that this is provided there. And the next thing is which is the financial cash flow analysis, how you evaluate the projects, but I would prefer to do this after lunch. So I prefer now that we work and you ask questions and things like that, rather than this presentation.
Yes.
Yeah,
You're right.
because you need to focus on and the time. Okay. But I can start. I can start with the financial analysis because we covered part of it very briefly, and I want to say that you benefit. I read this out in second. I this in okay, yeah. Understand.
Can I go start with the laptop?
This is it. Yes. I have provided you here. Well. I have provided you with the very detailed description of profitability calculations. It's English, and I use artificial intelligence. Let's see how it works. To translate it in Macedonian. Let me see. So this is the in Macedonian, the same material, which describes in detail the calculations, how they use, what is their efficiency, pros and cons, because each model, each way of calculating stability, yes, its advantages and disadvantages. So this is provided here in 15 pages. So if you want to see that, where it's take away and so on, inflation, how it's calculated, this is again translated. Okay, but this is calculated.
Do we have this in English?
Okay, I will show you the English one, but this is for you to make your life a bit easier, to read. It's very good. This one is provided in Word format, so if something is wrong, it will make improvement. So this one is in but what we'll discuss is in what we'll discuss is in this is provided in English. This is the English original, that one is. So this is what I'm talking now in this presentation, which presentation is short. And of course, you'll forget most of the things I say. Oh, so please, I provided this with a detailed material. So if you want to make a reference, you go there and it provides examples and so on the calculation of profitability. That's the inflation rate. So formulas for calculation. Inflation rate, if you remember, I provided it already, but this is here is at the discount rate is this is the same nominal and so on. This is provided here. I provided this in the spreadsheet with formula to calculate it, but here is the explanation of that. One thing which concerns your banks, you know these things, but it's better to have this in writing. And so if you have to make a reference to that, if your client wants to justify, to explain all these formulas here, is the weighted average cost of capital. Actually, you don't need that. That's a very simple formula. Some people like it. I don't think this completely useless. If people are interested, can they pay back? What is my benefit? What is my profit? This is what they ask. But in science, you have to be explained that this thing exists. And net present value, which you of now, and so all the formulas are provided here, so you can calculate. Just to show it in some examples are provided here. And the calculations, how it's calculated. I will discuss in the afternoon simple model. I'll show the elaborated real shadow models which you can use, but they're too complicated. I'll show you how a core functions of a project, how they calculate it in a very simple model. But we'll do this after lunch when you're fresher or maybe sleep, yeah? And this is the explanation of internal rate of return with all the formulas and so on here. So this is it there here. Just to let you know that these things are provided. payback periods. As I mentioned, simple calculations, cash flow and comparison between these. I also provided, you don't need to do that. Levelized cost of electricity. I don't know, but this is levelized cost of electricity is of the interest of the electricity companies. Great operator. Otherwise, for economic purposes, in big projects, you build a project and they have to offer. Then they have to offer certain price for electricity on which they sell. Then you have to know what is the levelized cost of electricity, which I will explain if you need to. So not applicable for these projects. No need to do that, but I also provided this for you. And this is the profitability ratios and indicators here. To make a project, it has to have a net present value of 0. Okay. Discounted is less than period, calculation, payback period. Because if you have a payment of 20 years or 100 years, sorry, obviously it's not worth. Internal rate of return is more than your capital, cost of capital, obviously. Otherwise, it's no point. If your cost of capital is 7% and your rate of return is internal rate of return is 3%, obviously, it's not worth doing that. From your point of view, capital enrichment ratio, this is the ratio of the net present value divided by the whole investment. So on each invested dollar or pound, then how much you getting? Amen. And LCOE is the levelized cost of electricity is more than, for example, the less than this on the market. Otherwise, why you're trying to sell something more expensive in the lower prices. So this is the main ratios which we discuss. And but this is from the point of view of the owner of the project, the capital provider. From the bank point of view, it's totally different. They have different, and I'll make a presentation later on. They have different things. They need to know that you have enough money to pay your loan. So your debt service coverage ratio is higher than the threshold, at least higher than 1, obviously, because then you will not have enough money to pay. But usually it's 1.2 or it's above 1. The bank is very generous. It's usually 1.2, below 1.2, doesn't work. So you have enough money, the free cash flow, which is cash flow after you pay your expenses, tax, and after that, it's the net cash flow. After that, you have 1.2 times more money than your debt service, which was 1,200 pounds. You should have more, 1.2. So you need 1,400 pounds at least. So the bank can say, yes, we have enough cushion if something happens to the project. And you look at sensitivity of the project and so on. But this is the main things I wanted to say. Let's now go to the presentation, which was okay. Okay. We have historic and current statements, and depending on what is your purpose, you look at this profit and loss account and so on. operating costs, gross returns, net returns, and so on, net profit before tax, after tax, and you try to see, is a project worth investing in? First, as a equity holder, as an owner, and second, from the point of view of the banks. There are two sides. It's not only that the project is very, you may design a project very profitable to you as an investor, but it doesn't suit the banks because their ratios, their interests are not sufficiently protected. It creates most uncertainties and doesn't provide them to have certainty that you can pay the amount. Because for them, one thing I want to say now, the banks do not care for your discount rate as well, for your profit as well. They don't. It's your business. They care only that their loan will be repaid. Don't show your bank, oh, I will make 27% internal rate of internal money. This doesn't concern the bank. They don't care. They don't. The bank cares that you can pay your loan. You have enough money after you pay your expenses, your taxes, to complete their loan. It's what they care. And also after finance. So this is, don't forget that. Have two sides. These two sides, they have to be satisfied. Otherwise, the project doesn't work financially. If you make a very large return, but the bank doesn't get the ratio satisfied, doesn't work. If the bank is happy, they may ask you to provide 70% equity and 30% loan. They have great ratio, but that's not for you. You have to decide. Have to satisfy, find a workable, beneficial for both sides balance in the project. So I have these historic things. I'm not going to describe what's balance sheet, you know that. So let's keep that. And the ratios, I just showed it. Right? There are different ratios, terminal sales, asset turnover, and so on. This is for trading. Energy efficiency is a bit different, as I showed you on the big document. This is accounting methods for company which produces something, sales, and they have assets, and they look at the turnover of the assets. So you have machine which is cost 1 million, how much you make out of it? And if the life of the economic life of this machine is 10 years, you have to calculate, is this okay to spend million on this equipment or not? If it's not worth investing in it. And so these accounting ratios, which are not very important for us now. Now we'll come now to the other important ratios, and this is the debt service coverage ratio, which is the probably the best thing is to put a model, and so you can see the numbers. Instead of explaining this abstractly, we can work on a project. So let's this. I prepared a very, very simple model here for you to look. I'm afraid, however, that this is Okay, that's fine. So a very simple model which covers two, you can change only the numbers here, the blue one. Others are protected, not with formula, but they're protected. You can just unprotect them if you want to see this, but not to touch them accidentally. They're protected now. So I put in this very simple model just to illustrate the core functions of the model is, for example, productivity. You buy a machine which produces something and saves some energy. And the cost of this production is per unit. You sell something, I just put 180. And the price of electricity is 10 cents. But you can change this, whatever you need. And in this case, I put this is like a solar. Yeah, it was solar. So we have 140,000 generation per this will be 100 kilowatt hour, 100 kilowatt project, which will generate 140,000 kilowatt hour per year. This is a project in Negotino. So person Negotino. The price is 20, and the capital cost is 78,000. Fixed costs are 17%. Fixed cost is the cost which you pay for salaries, for things, insurances and so on, which you need to pay. Working or not working, you pay them. It's called fixed cost. Variable cost are the cost, for example, if you produce something, you produce something, and as more you produce, more materials you need. This varies with your production. If you produce 5 things, you spend certain amount of money for materials, water, electricity, and so on. If you produce more, you need more. So this is variable cost. And I said here, this is approximately 30%. So it's a 30%. Actually, these people will make 70%, almost 70% margin. This is something costs $1, €1. 30% is your cost, 70% fixed cost. So you make something like 50% profit. Not bad. And I put some financial costs. Do they need to pay when they get a loan? Some fees to bank?
Disbursement fee.
Disbursement fee. So you pay. I put 1,000 for the whole project. For the whole 70, for the whole 50, 4,000, I put 1,000, maybe too little. I don't know. You can change it. You can change it. It just. So, and general things which you need to discuss is the tax. I put 10% here. This is 10%, yeah, 60%. 10%. Discount rate also I put 10%. Just to be generous. And the depreciation rate is 10%. Depreciation is for accounting purposes only. For accounting purposes to pay your tax. You depreciate the cost of your equipment. We assume that everything is a cost here. And this money is depreciated on a linear basis. If you want to see what is the explanation of these things, you can click on this red triangle and it describes what it is. Just for information. And so the depreciation is linear, 10%. So in 10 years, your equipment will be depreciated. From a point of view of the tax. Because this is calculated in taxes, not in cash flow. It's not a cash flow. It's a tax.
But it's
Depreciation, yeah, you know.
Our depreciation rates are higher than 10%.
So 5 years, no, 10.
Yeah.
5 years.
20.
For
equipment.
Yeah, for equipment, 5%, yeah. Because economic life of solar is 15 years. At least they say. Or more, but the economic, economic is because you have to replace inverters and so on and so on. So around 15 years. So this is why I put 10 years here. But if you have so-called accelerated, some legal regimes, country, they allow this accelerated depreciation. So you pay, it gives you some tax advantage. Because you pay less tax. Right. In the first, you pay less tax. So accelerated depreciation sometimes is used as an incentive, fiscal incentive. I don't know here, but you can change that as you like.
There is no.
Sorry?
There is no one.
No, I'm just saying that. And when it comes to the finance, of course, you have the same things, 30% equity, 70% debt, no mezzanine debt here, grants. Grants will be after that, so I can't. Yeah. So this is what you have to pay. The tenor is 60 months, which is 5 years. 5 years. Oh, interest rate is 5, I'll put 7%. And basically, is 0 moment, but you can put up to 12 months. Okay, and so that's what we calculate, and of course you have is the revenue? It's monthly. Monthly. Can you tell us?
Because mezzanine debt in this case, what should be?
Mezzanine debt. Mezzanine debt.
Factoring something more expensive loans.
It's a more expensive loans if you don't have enough capital. And the bank says, look, Mr. Kubov, you need to provide 30%. And
yes,
you don't have 30%. So, and they say you go and borrow more expensively from another bank or another institution. And this is called mezzanine because it's in the mezzanine. Not in the top floor. They're in the top floor. They'll always get first paid. We'll look at that later. But these mezzanine guys, they accept no risk.
Yes.
And of course, for that they charge.
Yes, yes.
So lately, the mezzanine debt is valued as the rate on return on your equity.
Yes.
The same.
Mezzanine debt can be also some kind of risk capital.
It is a risk capital. It's a risk capital. It is a risk. Yeah, it is a risk capital. So, and for example, in this case, probably in the range of 17%. But because we don't have this, I just read it. So, and now let's see now how this works. With the red numbers are the negative numbers, just so you can see that. So we have this 2,300 a month revenue from the generation of the plant. And the inflation here, I put every year, because the inflation you don't change. But in some regimes, the tariffs are updated every year in accordance with the Commission for Energy Regulation. They change every year on the inflation of the previous year. Is this a practice here?
No.
No? So they can update it.
No, they are the same.
Increase the price.
The feed-in tariff.
The feed-in tariff is different for the tariffs you set in the.
No, even the price of the.
Yeah, but if you have you can have here price adjustment. One is yes.
The government is
0 is
subventing.
okay.
Needs to mention, that's why.
Explain why the inflation is there. But the inflation is here as well, because every year you workers will say, look, inflation is, let's see what I see.
6, 7.
Inflation is here. I think that in 12 months, the inflation is 5%, which is approximately what the central bank says. could be 3% but I said 5%. And you say, look, this inflation, you have to increase our salaries. So then your fixed costs will go up. Because the prices of all these things get up. And of course, when the prices go up, of course, your expenses will go up. And your profit will be less. So this is what it calculates.
Yes.
And so the revenue is here is 1,000, the revenue is 2,000. The expenditures are 1,000. And you have depreciation for accounting purposes, depreciation, linear depreciation of 10 years there. And you pay tax. So that this profit minus expenses, minus depreciation, you pay tax. And you don't pay tax every month, but you may pay tax. I don't know. Think what I calculate every month. You go, and after that you have cash flow available for debt service. The cash flow available for debt service is 1,174. But you have to pay 1,030 pounds of euro, whatever, every month. Is this okay? So this is the ratio, debt service coverage ratio is the ratio between this cash flow and what you have to pay. And this has to be usually more than 1.2. Which is not the case here. Here is 1.12. So the bank will say, yeah, you make 26% profit, but our is not enough. It's not good. You don't like that. And so in this case, the bank will not be happy with that. What we can do? Of course, it's a lot of things. I visit that here is 5 years. Okay. So you can increase the period for instead of 5 years, you can make it 6 years, 72 months. And of course, the service coverage ratio costs which is 5. Because then you have every month you pay, every month you pay 879. Now is 6 years. So this is how it works. Or you can hold the bank here, but you want to repay it in 5 years' time. Then it's another solution, of course. Of course, it's another solution. Then you can pay more equity. Increase to, let's say, 35% equity and 65% debt. Okay. So there's a lot of ways. So in this fair, if you initial whatever you decided to do, 5 years loan, 30% equity, if it doesn't work, the banks have flexibility to see in what case project works.
So the revenue is here discounted or?
Which one?
Here, the first 2020.
Yeah.
This is discounted or not?
Oh, the discounted numbers are down there.
Okay.
They are here.
I do.
The discounted numbers are here. These are discounted dividends. The dividends here. Society and dividends are here. And you can see, for example, the first year, of course, it's a very, very small difference, but still you can see that it's totally 385 pounds from the point of view of future money, they're less valuable. This is inflation, 10%, 10% discount. This is the discounted. We need a discounted. Discounting is applicable only to the owner's capital, money, dividends, and things like that, not to the banks. The banks care for their debt service coverage ratio. This is what they care, that you have enough money to pay. You have enough cash flow, service for that.
That's the part that you're interested in.
Yes. But let's be clear that this is the case. And so this is the illustration of the debt service coverage ratio. This is the illustration of how it's calculated. So it's calculated on the cash flow available for debt service divided by the payment of debt loan for this period. This is for a certain period of time. For example, this is for January 2025. Calculated, you have this, you have how cash flow will get, and how much you need to pay, you divide it, and it has to be always usually 1.2, something like that. Not below 1.09. Obviously, you don't have enough cash to service your debt. You'll never provide a loan because you are signing a project which will be in default. Don't do that. So that's this measure, important, very important. So you can see better, sorry. And cash flow. Cash flow is very important. Without cash flow, the project is nothing. You need cash. Don't forget that. Oh, it has a big benefits, so I understand. I understand that it has big benefits, but it has to have cash. We borrow money from the banks, so we need cash. You may have the best intentions in it, but without cash, no, the banks pay you money. So you need to return the money. So cash without cash. So you have in the model other sources of cash if you need, you have to add them. But this is the expenses, variable, fixed expenses, so you need to have a positive cash flow. The appraisal is to see what's the return to investors and value to the businesses, and also you need from the bank's point of view to calculate the bank. This is a general thing, how you identify opportunities and so on. You have the process. The process will arrive in the US consultants, you have to evaluate them. So you need to evaluate the projects on their bankability. And here, very briefly, different methods of appraisal. Accounting rate of return, that's not very important. It's not very important. You're financing your project, not as accountants, but you go and borrow from the bank. This has to be guiding principle. So yes, you can see the accounting rate of return, just to give an idea. But very simply, you can start the payback period. Yeah, project. We say, all right, the revenue of this project will be 2,300 a month. Good. Okay. So, this is the rate, but I have to invest 78,000. How many months I need to get break even? And if this is 120 months, yes. Oh, probably it's not very good point. Too slow payback. It indicates that you generate not much cash. It's a very simple matter which you will see. So payback. How much, for how long you need to recover the cost of the project? Very simple method of calculation, which is very approximate. You don't use it, but this is the first thing. If a project costs 200,000 and generates 2,000 a month, would it be profitable? Would it be good?
Yes, one not.
Yeah. So not, obviously not. It's too long period for repayment. So it's probably say, all right, okay. All right, we'll come with better numbers and
Only for the big projects.
yeah, yes, so, yeah. Yes. And net present value is another method which looks at the net present value of the future discounted revenues, cash. Internal rate of return is the a bit precise, more taking into account discounting and so on. So it's calculates what's the internal rate of return to capital, and the profitability index is how much you return on each of. This is the very simple calculation. Average annual profits divided by annual investment. There you are. And you see, is this okay or not? So then different ways to do, which usually is usually we use this one, the average annual profits divided by the initial investment, and you see how many years you need to recover. This is used. It's very approximate. And of course, this method ignores the timing and future value of money and so on. So it's not a payback, just indicates for companies. And as I mentioned, there are at least 3 versions of that. So it's a very approximate thing, just to look at that, see the numbers. If it's 20 years, forget it. So very approximate, but it's kind of. And this is the payback. This is the money, the time needed to recover your initial cash investment. How many years need to recover, break even. And here, depreciation, of course, is accounting, so it's not taken into account. And you need to have the cash flow determined. I need to, of course, you aim for the shortest period. Say, oh, my project pays in 1 year. It's easy, it's good. But if your project pay back in 10 years, that's more difficult, because if they want to borrow money for 10 years, obviously it doesn't work. So discounted payback takes care that we can discount the future cash flow. You remember we discounted down there? Discount rate. You can take care of the discounting, so the future value of the thing, but still this is a very approximate very approximate, but sometimes they put a target, say, okay, we want to recover this in 5 years.
This is the most common here.
Huh?
This is the most common.
Very common, yes, yeah. Most common, not precise, but it shows, indicates waste. I'm not advocating it, but you just, when you get a project, you look at that. And this is an example. I don't think we should. For example, here, the initial cost is 8,000, and so the project is payback in 4 years and 4 months. Okay. That's okay. So very simple. I don't need to explain. This is arithmetics. You understand that. Payback. The payback is ignores the timing. If we discount it, it takes care for discounted cash flow, and but it doesn't take care of the life of the project. Something which is very much ignored. We had a short discussion. What is the economic life of the project? This is very different. For example, if you look at the solar power panels lobby, they'll tell you at least 25 years. At least 20, please. Reality, 15 max. Because I didn't put here this number, but very often in a year, 8 or 10, you have to replace the inverters. They're expensive. The panel starts to fail. Their productivity goes down. They say, oh, it's a 0.5% or 0.8%, but in reality, the first year, it drops down 2% or more. So in 20 years' time, or 15 years' time, you have 20% less generation from the same panels of the age. And when you have to replace the inverters, which are pretty expensive, and you have to replace the damaged panels because the conductors which take the electricity from the silicon cells, they degrade, they burn out. So suddenly, the reality is very different. That's it. The wind power is even worse. But even the solar is, it needs maintenance and also capital expenses to repair.
Energy more expensive.
Of course. You can see on the tariffs of the countries which has most renewable energy. This is expensive. But you can make it bankable if you properly account for this. Or replacement of capital items like panels, like inverters and so on, transformers. So yes, but this has to be accounted for. Otherwise, you will get distorted picture, something which is not. Discounted cash flow, that's important. So cash flow, as you see from the thing, you have cash flow and what to do with this. Obviously, the cash flow today is one thing, cash flow in 15 years time is totally different. So we discount it with the chosen discount rate. How you choose the discount rate? This is your business of the owner. As I said, my discount rate is pretty high. Obviously, but the companies, they have different staying power. They can stay in the market for 20 years. Some companies can shorter time. They want to be in 5 years. They want to get their money and go and live from Bahamas. So discount rate is different, but just retain that this technique is more precise, more clear what will happen with the project in the future. And the net present value, the method is very simple. It's a sum from the year one of the project, the beginning to the end of the project, and the cash flows divided by the discount rate. Just what was discount rate of one of the years, say. Very simple formula, discounting. Very often, it's one amazing thing. In Excel, if you calculate the discount rate using discounting with the formula, you'll see slightly different result when you use the function NPV from Excel.
Even sometimes Google, if you use Google spreadsheet and Excel, it gives you different results.
Yes. So
You never get the
Yes.
same result.
they have internally got most of calculates. It's a very small difference, but it's
Yes.
just to let you know. But you know, that's no. NPV has to be positive. So I looked at you, started to look at me with so let's have a lunch, put some energy, and we'll discuss these things further. Oh, switch off. Very. Stop share. Sorry, colleagues, we'll have a break. And so to continue the discount rate, discounted cash flow. The reason is to find out where. Where's microphone?
Ama zaraz szedł
Ja myślę za kamerę.
Przecież ty masz jej pana online.
So, if we say that our target for profit is 10%, 20%, we set this as a discount rate and see how the cash flows of the future meet your expectations. In any case, you have to be positive. If it's zero, you meet your target rate. You have target rate, for example, of 10%, 20%, set it as a discount rate, and you see with this discounting what you get. The sum of all the cash flow discounted over the years. And and from here it comes the calculation of internal rate of return. At what rate of return your NPV is zero? Your internal rate of return. It's useful, and as I said, I have to emphasize it again. This is for the owner, for the capital providers to the project, not to the bank. The bank has different things, and it's called debt service coverage ratio, which we will discuss. Or loan life coverage ratio. Do you calculate loan life coverage ratio? You don't calculate that, no. So debt service coverage ratio. So discounted cash flow have to meet your expectations for return rates. Or if you have a fixed, you decide that your discount rate is 10%, 20%. At this discount, you have to see what is the net present value of the present, because it's not. From today's perspective, you're looking what will happen in the future. Because the future cash flow of these days is different from value from what you have now. Return rate of return, as I said, this is the net present value This is a calculation because it's usually approximate. You see interpolation, but in the simple terms, as I can show you in the project here in the model, you set a discount rate, and at this discount rate, if any present value is 0, this is your internal rate of return. How much value the project generates? Internally. How much? What is the rate at which the project returns your capital? That's the point. One important thing I have to mention is you have different internal rates of return. Different. That's what you want to calculate. Internal rate of return on your equity, that's the most important. Because it's your money, your capital. What's the return on your capital input? Overall rate of return, this is not internal rate, this is economic or financial rate or something calculated. But this is for governmental entities, the interest, not you. You are looking at your capital. You put money, what to calculate?
The impact evaluator, they are using mostly.
Yeah.
Which model of
Impact?
Investment pre-accession for
For pre-accession.
Yes, so European Union.
How they calculate the internal rate? I don't know.
I don't know, because
No.
you are mentioning.
They just across the street.
Yes.
Not to go and ask them.
Different model.
But they're different model. They usually, this is from government point of view, you use the overall return on the project. Overall.
Yes.
On the total investment return, because they will, EIB provides funds, European Union to say, the accession funds. So they look at the overall
Yes.
return on
Yes.
the project. Overall, it's economic rate of return.
Overall.
In this model I provided you, I have made a calculation of overall. Just to see what it is. This is the overall return, this is the total investment. And cash flows discounted, that this is the overall return. But for purposes of specific projects which you help develop and present to the banks, then you calculate what's the return on the capital invested, and this is equity. So this has to be absolutely clear that the economic rate of return is calculated on the overall investment. See, this project is worth the money different institutions put in. And profitability indices, when they calculate the net present value of the future present value of the cash flows divided by the initial investment. Stability index. How much money each dollar will generate. And this is, as I mentioned, this is CPAR to look at that. How much money you invest $1 and you want to see how many dollars will be at that after 20 years, 15 years.
Discounted.
Discounted. The present value. So this is profitability index. But this, as I mentioned, this is from point of view of the overall economic viability. Overall economic viability. Because some projects are not financed by banks. They're financed by government funds. This is different way of evaluation. Here, they're financed by bank and they have to see they borrow money, certain percent from the bank, and they want to see that this project, after they pay everything, what will be the result? What's the internal rate? So we have a very specific subset, right? But overall, as Mr. Popov mentioned, that's different. He part to evaluate the overall economic viability of the project. And they'll calculate the profitability index, so net present value using an IRR using different criteria.
They asked NPV and IRR.
Net present value.
But on overall investment. So risks, I have a special lecture on risk, and when you look at the risk matrix, which I'll present in detail, just to say that risks are important, they have to be evaluated, and you have to show a very clear technique or method of managing the risks. Mitigating, avoiding risk, different strategies to manage these risks. Sometimes we avoid risk. Yes, but we'll discuss this specifically in the lecture.
Then you can try.
Now I will say a few words about sensitivity. It's very important. Sensitivity is very important. Think how sensitive is a project. When we look at the model now, we will see that I've incorporated certain scenarios for sensitivity. How sensitive is? Because in theory, bear in mind, colleagues, the financial models, like everything, calculates on certain assumptions. These things are assumptions. They're not reality. Reality is in the past. But we're interested in the future. Because the project will work in the future, and these people will pay their loans in future. But in the past, future. So we made assumptions. How correct are these assumptions? We don't know. Nobody knows. We try to be based on physical and financial calculations, but this is assumption. Nothing is certain. We say that, for example, inflation was 3%. Do you know what will be the inflation next year? We don't know. Even less we know what will happen in 15 years' time. This is guess. We say that the solar power plant will generate 1,400,000 kilowatt hours per year. This is an assumption based on calculations, but the weather changes. We had a project and the bank, I can say the name, the bank is Fortis. Now it doesn't exist, it went bankrupt. But we financed together large financial wind power plants. And they said, look, we financed 140 something wind projects, this bank financed. And from these 140 something projects, 120 projects delivered less than the P90 value. P90 is a probability of 90% that the value we assume will be generated. It's a very high certainty. Even that wasn't met, because between the years of 1990 to 2006, the wind in the world, not in this part of the finance, Europe and Middle East and so on, the intensity of the winds went down. Not the historic trend, because they look at the historic trend from the airport 50 years ago, fine, and they interpolate, and still long-term solar activity and things like that don't make an influence which cannot be easily predicted. So how we avoid these risks? How we avoid that? And we make, how sensitive is a project to certain factors? Like, we assume that the project in the bottom will generate 1,393 kilowatt hours for each kilowatt. P90. Fine. With the losses in inverters, with the losses of water. But now it's a peak of solar activity. This project will operate for 15 years, which is few solar cycles. I was sure that in 5 years' time, the solar activity will be the same and it will generate 1,392. No, it will be 1,200. Or maybe 1,500. We're not certain. So we have to check this with the so-called sensitivity. We change these parameters with percentage we decide is logical and see what's the impact on IRR, impact on net present value, impact on that service coverage ratio, which is important for you. And usually the banks, when they present the model, the banks say, look, I want this. I think I will find out what us to do. We want, for the worst case scenario, a certain combination of factors. Reduction of generation by 10%, increase of inflation by 5%, and what else would be? And price of equipment going up, price of maintenance going up. And in this combination, they ask us to run the model and see what is the result. Because when you go to the bank, we have to present so-called base case model. It's a part of financial documentation, like the assessment, the things from the National Agency for Payments, for Taxes, and so on. We have certain documentation collect projects, like application. And one of the financial documents which determines the rate, all these parameters, length of the loan, and so on, is the base case model, which provides what simulation of what happens in the base case. Everything goes this way, with these assumptions, what is the result? And it's called base case model. And on this base case model, you will ask them to say, how sensitive is this combination of increases and decreases? What will happen to your patient? Will you be able to meet my requirements for that service coverage ratio or not? It is called sensitivity. We change the key factors to see what is the result, which I'll show you on the model. And this is very important because this determines in your term sheet what conditions you will put. Like EBRD, provided the transit line, did the same. They evaluated the conditions, the overall economic conditions of Estonia, what will be the base rate of banks, Estonia, what will be the inflation, what will be the increase of GDP, what will be the liquidity of the banks. And based on that, they established the basic considerations of EBRD told you the participating banks, and they run their model, and they have also sensitivity. What will happen if the Bank of Macedonia, Central Bank of Macedonia, decreases their borrowing rate to 2%, from 6.1% now to 2%. Then their loan will be competitive. And they will say, now we have to see what rate we can offer. So this is attractive to the. So everybody runs this base case, and runs sensitivity to see how their projected investment works. So, any questions on sensitivity? You got the idea, and I'll show you this how it works in practice. All right, I explained this on, briefly, so we don't need to. do that. But for generation, as I mentioned, some banks, solar power, some banks require a 90% probability P90 factor, some require P95 factor. If you're very relaxed about this, they provide very good security. You can ask for P75%. P75% is 75% of the time of the cases. The generation we assume as base case exceeds the 70%. P90 is 90%. Okay. And we'll show this there. Any questions on that? Now, I provided a document of profitability. I did show you that in English and in Macedonian. Says it. But you have that documents, so you can read this if you have any question, any doubt about anything, and I can do it. Sorry? Documents there, the documents will be on the website of UNEC. All the documents. And I have them prepared here. And I'll give this to you, and you can share this among yourself, but they will be officially uploaded. We didn't upload them in advance because obviously this is a discussion only, something might change and we decide not to provide something or provide some more details on something else. So this is why we didn't upload them. They'll be uploaded after we finish. They're publicly available. This is the document I mentioned, the profitability calculations. This is in detail described in this document here in English and in Macedonian.
Can I have a question about the sensitivity? What variables are usually mostly looked at by, let's say, EBRD when they're doing the sensitivity analysis based on the base, base case?
Yes, the factors which influence the results most.
Okay.
Guess what? It's not interest rate. Interest rate actually has a very minor influence. Despite that, we spent usually sometimes weeks and weeks negotiating 0.5% of interest. Few basis points. They have minor effects. They have minor. The biggest influence is production. That's guaranteed. Another big thing is cost. And we have to discuss this when we look at the model. What will be the costs? Cost increase. After the bank approves the project, that's it. It went to their board or whatever is the procedure, operations committee board, and disapproved, and that's it. You sign it, and that's it. You say, but I need more money. No,
Inflation.
you have to pay. You have to pay from your own capital. The bank will never need increased costs because they approved their loan. They had to do a new project. New loan approval to increase the cost of the project. Because everything is calculated based on the assumption, not assumption, but whatever cost you can buy. So increased cost is not by you. For example, that's major. But the increase in production, is the biggest factor. I mean, depending on the project, few other things.
Yeah, the other.
For example, For example, if this is a project with high variable cost, for your production of something, you use a lot of energy, a lot of water, and workforce, so which is, and then your variable costs are very important. And if they increase, like the price of commodities, price of raw materials, steel, cement, whatever, they go up. And then your variable cost reduction will go up, and this is major. Well, and I'll show you what we have done. But yes, those are the major factors, which has the biggest impact. Of course, revenue is the biggest. Revenue and expenses. So you have this thing in detail. And if you need to read them, please, they're provided. If the lender requirements for tomorrow or later on, and I would like, we have now two important things. How the project looks financially, looking at the model, and also we provide business plan for complete. Write down, and we have a business plan answering these questions relevant to the project. Some things are not relevant to each project, but we try to be as general as possible. We prepare this business plan and the guidelines, how to complete this. While I was at EBRD, so I was used by the European Union, EBRD, and so on. So I'll provide this thing. Is available in English, obviously here, and I have it translated in 3 other languages, Russian, Turkish, and so on. But probably for you the most relevant will be Bulgarian. If you want to use it, I'm happy to provide it. Yeah, I'm happy to provide it.
English is okay.
English is okay, it's available. But privately, I can give you this in Bulgarian as well, so. Okay, so just to let you know. And this is I'll show you now, and I will share the screen now, as colleague said. Screen.
You have to open that, yeah.
Let's open this one. Okay. Share the screen. And let see. Share screen. Share. Done. So we prepared the short form to complete, which looks like that. You don't need to follow the fields in the project. So I'm doing this scrolling because I don't have mouse and it's very difficult. So this is the business plan 4. And you're asked to complete these fields in it. It's a full form. For your project, probably don't need all of it. You need a fraction of these things. And if the bank has an application form, we have to complete this. I will provide you example examples of few application forms. One is this full application form. Another one is short one prepared for the UNECE, which I'll show you. Another one is, for example, I'll provide the example of an application form to the Russian EBRD facility for Russia for energy efficiency. She prepared. I will provide you with all these examples of application forms. But now I want to show this general application form, how you complete that. Basic questions you have to answer to make the bank understand what is your project, what are the parameters there, and are they going to do it or not. You have to provide to them. These are project investors. Project owner presents to a bank to get finance. The form is long. I don't hide that. And as I mentioned, probably don't need to complete the whole thing. Or to answer all the questions, but to provide certainty to the bank in what they put their money in, you have to be as detailed as possible and as honest as possible. Honest. Ask your clients to be honest. They hide something because they don't want to say this to the bank. The bank, of course, makes due diligence. They go and check, they check everything. They say, oh, they haven't paid taxes last year. Oh, big correct. And after that, oh, you didn't tell them actually that you have very strong competitors on the market. You produce some. And you try to hide that. The bank finds out, they throw your project out. That's obviously you're not truthful. So we try to be truthful. It may not sound very good to you, but it's better to be truthful than to try to hide things, which after that, it's like in the family of wife finds that thing. And so it's not good. Better you tell in advance. So this form is long. However, to accompany it, we have this guide, which describes project, what you have to write, what we have to answer, how you evaluate the risks, how we evaluate each parameter, and this is called the guide for bankable products. So now, this is the business plan guidance for energy. I'll show you now that. Shall I share the screen? It's sharing. So this is the guide which describes, it's a short glossary at the beginning, which describes the basic, what is amortization, what is an asset, available cash flow, all these things is a short glossary to provide the explanation of the basic terms, balance sheets and so on. Current assets and so on, we try to, each of the terms used into the business plan guidelines are described here. For example, debt service coverage ratio is the ratio of available cash flow to the debt service requirement. And after that, I'll provide some general mezzanine loan is described here. You ask the question, we describe that here. And here is the guide to project finance business plans. That's the guide. You can use this to check against each of these how completed is the business proposal. And it's to be short. Okay? So you have the introduction to project risks, which is provided in separate. This is not part they don't write about. This is to guide you how you understand project risk, how you do it, how you prepare your risk matrix, which the banks have to prepare anyway in the evaluation, after that, after the general guarantees and so on, we go to the explanation. Usually this business plan starts with a short teaser, called short summary of the project, which provides the costs, the main parameters of the project. They have to be very clear. Well, the young bankers to read the whole application form and analyze it. The senior don't read the whole thing. They read the summary only. And the board needs 1 page summary of the project. They're not going to read the whole thing, obviously. But it has to be a good summary which provides all the key things on the project. So, I will have the financial appraisal and investment, and as you can see, we have to cover all the possible aspects of a project, from project size to initial review to financial projections to laws and so on. This is the banking procedure, not relevant. This is for knowledge. You don't write about it, but this is to understand how it goes. And this is the project summary, which comes to that. And it describes the project and the type of sponsor, contributions, finance requested, expected revenues, how we calculate. All these things are covered here. The energy prices, the market, the lifetime of the project. We have to justify what's the lifetime of the project. It's important because lifetime of the project calculates the net present values, internal rates of return and so on. You'll see now in the project. One thing is to say, oh, my project is, my horizon is 5 years. And now it's 15 years, totally different numbers. In 5 years time, because the loans of, for example, 5 years, the return will be negative because you pay loans. Actually, for the investor, it will be negative return. But in the long term, if they can afford that, 15 years, 10 years, 15 years, provides different results on NPV. So all these things are here. You provide this short, and after it's a business description, the nature, the risks, what they produce, what's their market, what's the current situation, what plans they have for the future. And nature of the project, infrastructure, everything has to be described. I've seen even in the solar, let's discuss solar. Oh, we will do this solar in Uzbekistan. Yeah, but the distance to the nearest substation is 200 kilometers. What's the value of this project to provide to the grid? Yeah, for self-use, it's not worth either. Because at daytime you use very little electricity, you need electricity at night. At night the solar doesn't work. You need batteries. Batteries are extremely expensive. They have short life because the Chinese have 3,000 cycles. So what to do? What to do this? And they have to provide storage for electricity for 7 hours, 10 hours. You can't afford this, it's very expensive. So the whole thing is completely useless because you don't have the infrastructure. So we have to be very careful. We make a mistake. I don't know how this consultants this, but this is the project power plant in Armenia. Armenia, the country is high in the Caucasus Mountains. They forgot. When they calculated the cooling towers, they forgot that the water boils at different temperature and a high altitude. They forgot, and cooling towers couldn't provide cool the steam from the turbine, so they have to work not with 90% or 95% of capacity. They can work with something like 60% because there's not enough cooling because of the altitude above sea level. Elementary thing, but people just miss that. They got ready project for somewhere in Indonesia, put the number, copy paste. Nobody took that. Doesn't work like that. And so you have to be very careful with these things. Infrastructure, roads, railway needed, transmission lines for your projects, and so on. That's very important. Because very often they want to build, and the electricity company, distribution company said, sorry, we have to change our substation because you want to put another 10 megawatts into the grid. But our transformer there cannot absorb this because the capacity of the transformer is lower. So they have to change the substation. Put transformer, switch gear, everything, which is very expensive. I said, for your project, I'm not doing that. Goodbye. You build your own substation. With the cost of substation to the solar project, forget it. Obviously, it never pays back. So infrastructure, very important. Just describe exactly what is the infrastructure and that your project is there. Very often, we don't do wind, don't do trees, never. It's so complicated. They want to build, going to city.
Yeah, we can press a button.
And you have to build roads to transport these huge things somewhere in the mountains to generate few megawatts. Not that I'm negative against renewable energy, but that's the reality.
Then we have been passed through, we will be constructed 50 megawatts with energy. The right side.
Okay, yes.
They will construct 50 megawatts.
So wind.
Staronego region.
All right, Macedonia is a rich country. It looks like, yeah, exactly. Because you pay this through your tax. Nothing is free.
Of course.
Nothing in the world is free.
There will not be a feed-in tariff, but the electricity will go on the regional market. So they will sell the price market.
Yes, and the regional market, guess what happens when it's windy in Macedonia? It's windy in Greece and everywhere around. So who is going to buy it? Just a question.
It's the same with the solar.
Solar is the same. Yeah. I told you, 15,000 megawatts in Bulgaria they want to construct because this is according to the European legislation. The commission there have to accept each application for renewable. They cannot say, look, renewable, get lost, I don't care. But no, you have to. And all the speculators went there and said, my application. So you have 15 megawatts for a system which is maximum 6. 15 additional megawatts. How do you manage that? Oh, sell it to the market. No, sell to the market. But they don't care because it's a long story, I'll tell you some other time. My point is that you have to write all these things which are relevant. Of course, railway is probably not relevant to your project, so you don't write about that, obviously. But substations, transmission lines, roads, and so on, they're very important. Legally, even access. Very often we forget that you need an access to your site. Access. You need somehow to allow it, because you can buy a field in the middle of nowhere, and you want to build your solar farm. Yeah, but you have to build a road to this place, the transmission lines, and your neighbors might not be happy. or may not allow it. Say, it's your business. I'm not giving my land to you for you to build the road here. So you have to ensure that legally everything is there, land, permits, access, everything has to be there. And this is what is described in this guides. We try to explain as much as possible that all these things have to be covered. So you have a complete application. When you go to the bank, you have all these things. Because the worst thing is when the banks ask questions. You have to avoid that. The bank should read and say, yeah, all right, that's clear. If they have questions, this makes your project application much more difficult because they have questions. They question something, which if you question something, you have some doubts about it. So you have to make it as certain as possible. When they read it, they see that everything they need is there. So they don't have questions in the best case. Or if they have questions, they're not critical, they're not fundamental questions to your project. So please try to answer everything. So they have said, all right, yeah, okay, this, that. So they have checklists on the project appraisal. So you tick all the boxes on the checklist. So they don't have any unanswered questions. Because unanswered questions is doubt, is something which creates uncertainty and so on. And the bank saying, this is risky. It's risky. Let's not do it. Or if we do it, let's they charge them lots of money. So this is to be as detailed, as truthful as possible. So this guide is long, I'm afraid, because it is not the whole thing. You don't need to write about everything here, but it pays to be precise and detailed. And yes, it's the same. This is the financial. The last one is the financial modeling. The sensitivity analysis is the base case model. It has to be. Would you like? Maybe not today, but tomorrow morning. I'll show you an example of term sheet. Probably your term sheets are much simpler to small project, but I'll show you a term sheet of a big project so you can see how it works, what the banks are looking, how this works, how the cash is distributed, how the so-called waterfall. When you get cash from the revenue from the project, how it goes down until you get your dividend. People are there for the dividends.
It should be a teamwork. Only one person couldn't do it.
No, of course not. Actually, it's not very complicated. It's not, but you need a financial specialist, you need technical specialist, and so on.
And legal.
And legal. Yes, obviously. But it's not terribly complicated. It's not terribly. We try to explain this much as possible in detail. You read and you write. In the form when you do few projects, you can see that actually it's the same and so on. You don't need to invent anything new. We try to provide as detailed as possible. This is 100 and something pages, obviously. Proposals have to be precise and clear, not long. Long writing is not very good. Nobody reads long things. They want something to the point, sharp, clear, answering their questions. And their questions are, as we see in a moment, what they're looking for. There are two sides, the investor side, capital. So, if you want to go down there, this is how was the purpose of the guide and the plant form. The form I did show you. They will be provided. The form is provided in Word. In Word format, so you can write, or your clients can write on it. And the guidelines are provided here. As I mentioned, I'll provide you a copy in Bulgarian, which I have. If you want some other language as well, but not in Macedonian. If you want, we can translate it. English is okay.
No, I was studying also couple of years in Bulgaria. The terminology is not the same. The language should be are very similar, but when you are going through the documents and
You're telling me.
it's totally different.
Do you know that I have this university? I had a problem since I
Basic language is totally different.
They use some strange terminology which I don't. I'm honest. So I prefer to speak in English better because I know the English thing, but I will provide this service.
In English is better for us.
Yes. In English, it's available, it will be shared. The Bulgarian version is, of course, for private use if you want to use it, but it officially is the English version. So this is, first it starts with the introduction to the project risks. Main risks. Like sponsor risk is sponsor risk is the risk of the borrower, risk of the owner. Sponsor. And they're risky. They're risky. But not EBRD, but after that, I worked in a financial company. We used to do a very thorough due diligence of the project owners. Of course, because now, particularly now with the money laundering regulations and so, we have to be sure these people are proper. And you check, and you can hire private companies, very secretive, private companies to make are they going to divorce the main project sponsor? To that extent. Because then the capital base is changing. Because his wife may get the capital and disappear somewhere, or divorce, get them out of the money. You check, are they proper people? Do they spend their money properly? Because some guys, and finally, this consultant discovered that this guy spends too much money in gambling and prostitutes. Not a good reference. So the people who finance the project. Sorry, so project risk is very important. Pre-completion risk, let me say only few words. Pre-completion is the risk before the project is completed and start generation. It's the riskiest period because the money already in, but there is no revenue. And how this is covered? What are the completion guarantees? Because if it's a contractor, they have to guarantee that this project will be completed on time and on budget. And you have to check this pre-completion risk because it's very important. And you have to write in the proposal how this is arranged. Completion risk, the project is completed, but it doesn't generate as what's promised. Because of the panels, and the losses in whatever higher, and so on. So you have to explain that. Also, in a solar project, you have degradation of the modules. One thing is to buy modules which have 0.5% per year degradation. One thing is to buy panels which have 1% degradation. So the performance is different. And also, temperature-wise, in some places is getting too hot in the summer, their performance drops down, and of course the production goes down, and we have to see how this thing is covered. Do you have provisions for that? How you accounted in your model for that? Technology risk is that the technology will obviously fail, or if you want to use some unproven technology, some solar panels with cadmium oxide. Yeah, but the banks are not sure that these things work. They're not proven technology, or they want to buy a machine which produces using some new unknown technology. Of course, I'm a bit scared about things like that. So technology risk, you have to explain technology, how it works, and how this is Input to supply risk, that's very important, very clearly. So if you need more raw materials to produce your thing, have you gotten access to that and so on? There's big risk. Have to be explained that you have everything covered. For solar energy, this is the solar. You have to prove that you have this solar radiation and you adequately count this in the sensitivity. The production may go down. So you have to explain that in the input or supply risk. Operating risk, your operators cannot be bothered to go to clean the snow from the panels. I saw this yesterday. So you have to explain this operation risk, or they don't maintain the technology, the things got broken, they don't generate, and you have problem. Of course, this is somewhere at the end. Approvals, regulatory risk, but this is, if you ask me, it's in the top. Because this is the most difficult thing. Approvals, connection to the grid, operation permits and so on, that's extremely important. Environmental is also, maybe the local people don't like it. Don't like it. They just don't like it. Or in Middle East, we had this project, they started to shoot at the panels. They don't like them for some reason. That's it. They don't like them. We can't stop them. They have, a lot of them have weapons. We just shoot them. Fun. In Africa, they throw stones on the panels. Simply, they don't like them. People used to break the noses of the statues. Why? The same thing. Something new, they don't like it. Break it. And socially, have to be accepted. Here also, it's a big problem because they start to classify arable agricultural land, to classify it as a third or 10th, whatever category of land, to put solar panels on top. And the local people protested because it takes long plants to put solar panels on it. And this is a social issue. I put it as an environmental risk, but it is a risk. People don't like it, don't approve it. At least in Africa, you see, they go there, they meet you nicely, and you have to pay the local tribe. Because they don't live, they're nomads, but they don't own them. They don't have those, but still they consider this their tribe's land. And you have to go, agree with the chief of the tribe. You sit under the sacred tree, and you kill a goat, and they cook the goat, and you eat with the tribe chief, and this is the sealing of the social acceptance in the project. Yeah, in Macedonia it doesn't work, so goats are safe.
You have some that kind of experience in Africa?
This is why I said. But in Macedonia, the goats are safe. I don't think they will do that. But it is social. And off-taking salaries, this is also important because this is actually the people who say off-take, take your electricity or your production. And if they don't, you're in big troubles. So that's you need to show that you have all the permits, all the connection, everything, and that they're going to pay. That's the most important. To pay. The big projects, we had to go evaluate the capacity of tethers for the Turkish company, that they have the capacity to pay to connect. When you connect this project, they have the capacity to pay. So you have to evaluate the credit worthiness of the buyer. If this is the state of big electricity company here, you don't need to do that. But at least that's important because depends on the project. So if you produce something, this is for photovoltaic, but if you produce something and you have to sell this equipment, just produce something, plates. And be sure what's the economic situation in the country and the capacity of people to buy. Because if the situation is bad, high inflation, people don't have money, they are not going to buy your produce. So you have to prove that your market works. And you have, somebody is buying it. And the best thing is to buy a contract. You sign a contract that in the next 5 years or so, somebody is going to buy your produce and they guarantee you payments. That's the best. This is how the power purchase agreements work. Long-term contract, they buy, you feel secure, the bank is happy because they have certain offtake. Guaranteed, payment guaranteed. That's the best. Power purchase agreements, long-term. But for small projects, I don't think that is an option. You have to cover that. So this is the risks they described in detail here. Completion technology and so on, so I'm not going to repeat that. And here we do prepare a risk matrix. It's for big projects. I don't think for small projects we're doing, but I have to show you that. This is the risk calculated in three methodologies. One is Haynes. This is risk is equal to the severity. How big is the impact? How severe will impact your projects? Multiplied by probability. This is some, for example, fires, which will destroy everything, of forest fire, for example. But the probability that this happens is very low, but the risk is the combination of these two. How severe it is multiplied by the probability. The probability is very low, of course, the risk is certain. And the other way to calculate is how severe is the impact, multiplied by probability how often this thing happens. If this thing happens once in 100 years, but your project life is 15 years, obviously the risk is not very high. But if this happens every 3 years, in your life of the project is 15 years, this will be quite an impact. And so the risk here is different, of course. Tiers risk is from the purchaser of electricity, the utility, to the project management, to the hardware, equipment, to the environmental and social acceptance, and the government as a top risk. Because the governments tend to change their laws. They change the regulation. For example, just to give you an example, now renewable, European Union, you say something, they just die from happiness. And now everybody jumps on that because Greta Thunberg said that. But imagine economic crisis, wars, as you can see, we don't have money. In 5 years' time, the politicians, if they want to be elected, will forget suddenly Agenda 2030, 2050, and so on. I want to be elected the next elections. I want something which appeals to the population. Suddenly, these things will be forgotten. So, you propose something. Not economics, not in our economic interests, goodbye. So, it's extremely important thing because government sits on the top. They may change their language if they wish. If they can change. I remember vividly when the first project we did in Italy, the tariffs, and in Germany, the tariffs were 52 cents per kilowatt hour. 52 euro cents per kilowatt hour. And subsidy. Then electricity. The electricity. They say that. They say that. And then the tariffs in Germany were something like 20. 15, around 15 15 €. So 15 €, they offer them 50, right? The difference. And now this sector is not like that. And these things change. You have to accept that, and you have to be very careful when we deal with government, because they can change the laws even retroactive. Do you know what they did in Bulgaria, for example? They gave tariffs for these renewables and so on, special feed-in tariffs and so on. And suddenly they realized that it's bankrupted the country. Everybody applied for it, everybody goes and installs panels and get this very high 35%, something like that tariff. At the time, the tariffs were 5%. And the government said, okay, all right, okay, we cannot change the tariff retroactively. We offer to that, but you have to pay the transmission cost. Because you visualize substations. And of course, how much you charge it? It's all right. It's 8 cents. So it suddenly, your very profitable project became not so profitable, going into loss. So government is very important. And we can cover it even. And I'll just say a few words about the control risk strategies. So, best strategy for risks are there. Can't change, they're there. But the best strategy is to avoid the risk. Avoid it. If you can. For example, you have to build a building in an earthquake zone, you don't build it. You avoid the risk. Certain. Avoid. And mitigate. So you can mitigate the results of the risk. You can mitigate them. You can reduce the probability of this thing happening, better protection, for example, protection from strikes of but strikes and so on. We can mitigate this risk. I'll give an example of solar project which we did in somewhere in Nigeria, I think. And the most use is this and transfer. Transfer or share the risk. For example, in any case, you share the risk with the bank. You share it. Finance, you have risk, and you share it with the bank themselves. Or you share the risk with the transfer the risk, for example, is to transfer the risk through insurance or through contract. You have someone supplies the panels, they provide you with a warranty that these panels will operate in with this efficiency, degradation, and so on, temperature and so on, in the next 15 years, 10 years, 5 years, whatever. So this is your transfer of the risk. Transfer the risk to them. Something happens, I'm saying, dear supplier or dear contractor, you promise that this is the contract, it's with the deposit with the bank as a security document, and please be so kind to honor your obligations. This is a transfer of the risk. Transfer the risk to them. And acceptance is just to accept. Certain risk happens, prepare adequately. And there are a lot of strategies to prepare for that. For example, I'll show you in a minute, if you're interested, the solar radiation is not constant over there, it's very different. I'll show you in this project in Negotino. In the December of January, the solar radiation and generation of electricity, something like 60% less than in June. Obviously, and you accept that. You accept that, but the bank will ask for their money every month. They don't care it's in January. They say, no, you pay. You said you pay every month. How you deal with that? And I'll show you the end. Although we have prepared that service reserve account, special account, where you accumulate usually 6 months debt service. In this case, probably 6 months, too much, probably 3 months solar, where you keep money. And because of the solar radiation is low, generation is low, you don't have enough money to pay your debt, you draw from this account, that service reserve account. And you pay, service the debt to the bank. And in May, June, July, August, you accumulate money in the account. Feel it. So when September, October, November, December come, you have money in your account, you can pay your debt. Is this a practice here? That service reserve account? Lina and Stephanie, do you insist on that service reserve account or not?
No. Sometimes the banks take some minimum amount as a cash deposit.
A cash deposit.
So it can cover 1 or 2 installments.
Yes.
So
it's the same.
cases, and when the bank uses,
Yes.
then
You have to feel it.
you have to review
It's the same.
some.
It is the same.
But
It's the same.
It's
Yeah.
exceptional.
No, but I mean that you can offer. And to be prudent, very often we increase, we will put this cost. Calculate a few £1,000. A project like this, 80,000, I gave, for example, it's just 3,000-4,000. It's not enormous amount of money. You better put it in the cost of the project. So you have this account put somewhere in such cases, which makes the life of the bank and the project sponsor owner much easier, much less problems, because you have money to draw and cover any deficiency of it's prudent thing to do. So you can do that, and here I provided an example of risk matrix is called. How you do it, what you do. For example, performance of technology doesn't operate well, slower yields, low generation, lower yields, and lower revenues. And it's calculated as a loss reduction multiplied by the tariff. It's very important impact. And frequency is continuity. If the technology doesn't work, it doesn't work. And so very high impact. But we say the rest of the risk distance, as well, because the technology is proven. All the components are properly dimensioned. So you don't have, for example, in solar inverters with a lower capacity, because then they'll fail very frequently. So this is properly done. The wires, the transformers, everything is properly calculated. And most importantly, you have manufacturer warranties. They want that in their panels will work properly. And the risk control strategy is transfer, because you transfer this risk to the manufacturer, to the design. They are responsible. And this is the manufacturer, this is the contractor inside the project. And here we explain why. So the whole matrix is built on that principle. First is technical, after that you have financial risk, energy resources. This is the calculation of the feasibility studies and so on, and who is responsible for that. We have severe weather events, because it might be wind conditions, temperatures. This was a project in Nigeria. And you have storms of sand, not very good. You don't have these things in Macedonia. Snow. You have snow. Flood, sandstorms, dune movement. Yes, because they thought in dunes and they move. Here you don't have that, at least that's easy. Earthquakes, no. And the cost forecast capex. This is important that the capital costs. If they will calculate it one thing, and because until you calculate, prepare, designs, tender, whatever you need to do, the price will change. Unfortunately, these things happen. And now the cost of commodities and so on goes up, unfortunately. So this is quite a significant risk, and you have to be clear who meets this increased cost, how you meet them. As I mentioned, after the bank approves the project, it's not their business. You have to find other funds to pay for the whole thing. You can't go back and say on a project, sorry, we came with a project which is 100,000 and borrowed 80,000, but suddenly now it's 120,000, give us more money. It's not so simple. Probably it could be done here, because, but yeah, but generally it's better avoided. OpEx, I say, my operation capital, operation expenses, and so on, construction risks, and so on and so on. So this goes the whole thing to cover all possible risks of take that the company doesn't pay, doesn't buy, financial risks, currency, inflation. Are they borrowing in dinars? They're borrowing in dollars. So they don't have currency risk. But in other projects you have.
Long-term loans are in the euros. Might be in dollars, but indexed to euros.
Indexed to euros.
Yes, with a significant change. Exchange rate.
It will be, so it will be, you will have a currency risk. In dollars. Vulnerable people. Prince hedge. It's the rate. You provide loans, variable, floating, or is fixed?
Floating.
Floating. That's what.
Connected to LD.
You theory, it might have some fixed periods. Floating.
The bank has the right to change the interest rate because it's the market.
Yeah.
Market.
All right, so yes, this is also risk.
But in general, they avoid. In general, avoid. If they made a contract, avoid it to.
No. There was a huge increasement in the loans disbursed in the past. Имаше всяка имаше студент, може не толкова, но никой не може. Ако се одейти, да ни кредити со фиксна карта.
Добре, ама 90%.
Со фикс.
Со фиксната е друго, иначе сите што имаат променлива камата, сите добија нови амортизациони.
Тие што се со фиксна што ти вика има услуга што има графична промена во Renewable, има право.
Има право.
Yes, subvenționare.
It's a market flex, it's called, yes. Să ima pravo da
Може би нека сите со толку голем износ како при новите кредити, за да не предизвикат за да не предизвикат револт, може би не. Така, ако бил кредитот со 5%, новите ги давале со 7, нови му качиле на 6. Нема да му качат на 7 на постоечкиот кредит. Ама покачување имаше на сите.
Сите, ама не на постоечки просто. Обично тоа го суштува, ќе сега. И онака се разочарани сега по-ново.
Кај ќе идат сите други?
Новите кредити се со повисока камата.
Кај ќе бегат?
Знаеш, кога се презема, кога ги преземаат една од друга и даваат побула 5 знаеш.
Ама тоа ти е краткорочна мерка.
Ева добро, првиот
До година пак ќе му е.
кредит, после
Е тоа некоја...
После чуди го трес.
Да.
За рефинансирање.
знаеш.
Се решава. Се решава.
и банките трябва да живеят.
Много живеат.
Ако го затвориш кредитот со средства од друга банка, со кредит од друга банка, банката која ќе ти издава кредитот има право да ти наплати или проценти провизија за затварање.
Затварање на остатокот од кредитот.
Ако затвориш со собствени средства, не сме да ти наплати.
I would like to ask one question which is not related directly to this, but has something to do with the, you said about the banks. Like, okay, for the energy, for example, we have a regulatory commission, right?
Yes.
That regulates the, because it's the commodity that is sold to the public. We have to protect or just to have these margins of the utilities controlled, like 10%, 8%, whatever. Now, we have the banking system and their banks, in Macedonia now 14, 15 banks. And we have a central bank who is the regulator for the banking system. Now, the central bank doesn't do anything to protect the population from the increase of the interest rates of the banks.
No, it's not their role. Central banks don't do that.
Why is that?
No, central bank has a mandate by the government or in the UK, it's independent. Bank of England is independent. Not politically influenced. Their task is to control the monetary flows in the country, the inflation, is the task. They have to maintain a certain level of inflation and banking stability. It's not their business to protect customers, to protect population from what the banks charge them. If the bank wants to charge 30% on their loans, they're free to do it.
They're free to do it.
Nobody will go and borrow money from them, obviously, it's their business, but this is not the role of the central bank. Central bank has a regulatory and monitoring role. Doesn't have anything to do with protection of population. It's a totally different ministry. An organization which is for the population protection, but not the bank. Central bank doesn't have it. Central bank has limited arsenal of dealing with inflation, which is to increase or decrease the money flows and
Liver late.
yes.
Liver rate is Bank of England or
no? The Bank of England, the Bank of England provides the so-called base rate.
Yes,
Yeah, base rate, that's fine.
They decide, it's a monetary policy committee. And these people meet and they discuss what's the economic situation. In one room, in the central bank, I know my daughter.
Within financing, within
But in the central bank. And they meet, they discuss the economy, and they decide, oh, the market is overheated, we have to chill it down, cool it down. Increase the
In our country, the central bank regulates state bonds and
Yes.
state obligations.
No, they don't regulate.
In Macedonia, they are regulated. So the central bank can increase the
Base rate, yes.
interest rate of the average and the banks automatically increase their interest rate.
Because this is, they set up the overnight rate, they set the base rate.
State obligations, državnički zapisani is called in Bosnia.
This is the money which the banks keep into a central bank. They'll have different rates. That's how they regulate it. Yeah, skip.
Yeah.
And this is what the bank does. They don't, the bank does not regulate the bond. The bond is regulated by the market. If they increase the base rate very high, and the people who buy the bonds say, so the economy of Macedonia is very tricky, very shaky. Then the bond prices go up.
Yeah.
It's fine, everything is, it's okay, the bond price go down, but it's not the bank to regulate, no. The bank doesn't have anything to do with the bonds, even government bonds. No, they're regulated by the market, who buys, not who sells it. I may wish to sell my bond with coupon of 0.1%, nobody will buy it. But if I offer 5%, they may say, oh, fine, I trust him, I'll buy his bond. But this is not the role of the bank. The role of the bank is to set base rates, and through money supply of M0 and M1, they control the money market country and cool it down or increase it to try to control inflation. But this is that. And of course, they have regulatory functions that the banks have adequate ratios, liquidity, and so on and so on and so on. They look at these ratios, they look at the banks are regulated, and this is their role, but not sovereign bonds or anything like this. Base rate. So the base rate of the bank now is 6.1% or something like that. 6%. Something. 6%. You know, this is why I have bankers here. Tell us that exactly. So this is the role of the bank. Yeah. Okay. And also they also have important custodian things. They keep the gold reserves of the country. So insurance, this insurance, you have to provide adequate insurances on equipment, services, so. This is the different methods for calculation of how we calculate the capital cost of the project, what's the impact of that, and how we calculate depreciation. All these things are provided into the guide. Different examples. We try to be as detailed as possible, so it helps you to understand that, but you don't need to write. This is a guide. The form to write is actually form. It's not this. The form is quite, it's much simpler than that. I will provide the example of application examples. I provide few applications. For example, this is an application which you can use. Sorry. It's from a credit line for EBRD for energy efficiency. And this is the form which we use then. And this is, as you can see, it's description of the company. Here, if you use this form, you have to change from rubles to dinars. But okay, you can do that. And the balance sheets and so on, this is full questionnaire, the energy consumption, what you do, from where you save money. Yeah, all the prices, all the tariffs you pay. And G is the greenhouse, because it's part of the project here. Sorry, I just got it. Do you have greenhouse gas emissions management? Because some companies, they have this thing, others don't have. But say yes, we do have it. Be careful of that. And what projects you have, energy efficiency. And here, a few examples of energy efficiency, just to tick the box to be made easier. And implementation period, very important for the bank, for see how long it will take to implement the project. The lifetime cost of equipment. This is much simpler form. This is renewable project. There we have hydropower as well in Russia, but here you have only solar. So is biomass considered or not in this project? Biomass?
Biomass. Gas is not considered, but biomass.
Biomass is considered, okay. So we have biomass is there, geothermal, heat pumps, I think, and so on.
For heat pumps.
And total cost of investments here, everything is. So motivation. So this is a very short, and here cash flow, very short form, presenting the financials and the details of the project. This application form. If the bank likes it, they can use it. If you won't like it, you can use it. It's provided to you as an example. Okay. So this is clearly the first there. So you have this form provided to you. I don't think we'll distribute it officially because it's obviously not, but for you, you have that, you have adopted.
Тебе нормально выслушать текст?
Да, ну да, какие-то правки. Sorry?
We speak about the document.
The form, okay.
No.
You can use it, please. You have it. In fact, you have short term, but I'll provide you 3 or 4 application forms. Use which one suits your project. You have to modify it. If you need help with that, I'll be very happy to help. Modify it and so on. So continue with the guide, we continue all these costs, fixed costs, total cost, expenses, a fixed cost, variable cost. I don't want to explain this in detail, but if you have any question, please ask. Because you experience, know that you experience that project. I don't need to explain the very basics of that. But if you have any question on that, please ask me now or send me an email. I'll be very happy to help. But this is an example how we calculate these things. So everything is calculated in the same manner, consistent. Not project by project, they are different methodologies and so on. For the banks, it's very important that you have a consistent approach, consistent method to calculate, and they know it, and everything is clear and transparent. They know we got this. This is calculated how it is calculated, not every time you use different. Because this is the problem, and this is why I will show you so-called shadow. Because each company uses their own model. How they calculate things internally? What they consider, how they calculate their internal rate of review of return? How they this is their approach. We don't know, and they take different parts of the cash flow to calculate it. One company uses a bit, other uses a bit, and so on. So we have to be clear So when you present it, one consistent method, and you agree, and the bank knows it, how these things are calculated, what they're written, and so they can read it in a much more structured way, much simpler, but not every time trying to guess what they wanted to say. So this is the, yeah,
Can you make 5 minutes break?
absolutely. Sorry.
I think we actually can have a coffee break.
Because like a coffee, yes. Thank you for reminding me. Colleagues, we should, you're tired, I know that, but we should finish this thing. And if you're interested, I can show you how the model works. An example of other models, if the banks, for example, tomorrow are not available, to show you commercial models, how this thing work, how we calculate it. The guidance here is very detailed. You should use it to read what you need to write in the proposal. I strongly suggest to use some simple form, which I provided 3 forms. Or use completed so you can present in a very short, very presentable, very simple way. This is the projected financial parameters. This is the example base case model. This is what the project is, very simple. Project summary, very simple, very clear. After that, the detailed information, all the annexes. You have provide this annex as much as possible as annex, because the people don't need to read long things. As I mentioned, the junior bankers who read more, the senior bankers don't read. But fortunately, the senior bankers take this decision, not the junior bankers. So if your project is too long, description too complicated, too convoluted, they just say no, and that's it. So please, but this guy goes to describe all these things, how you calculate the cash flow, you have examples, all this, how payback is calculated, and so all these things are here. All the things are here, what we discussed, they're in the guide, so you don't need to go, you just print it or just look at this on the website, or you download it, obviously. And here are the examples, and the payback period here, this is illustrated, and advantages and disadvantages of the whole thing. Discounted cash flow here is discussed in detail, examples, the formulas, everything is provided. Everything is provided. This is even without now in the computer, you don't need to do that, but before people used to calculate it. Even Excel wasn't very much available. So here 10%, 10%, and 20%, and some discount rate, what will the coefficient of, for example, with 24% discount rate in year 10, from £1, you will get 11 12 cents. And that's the value of this money in 10 years' time. I just not
rate 24%.
But 10% is still 39 cents. Imagine. This is the value of £1 in 10 years' time. Because we discount it. And this is compounded every year. It goes up. All this calculation of these things, as I mentioned, they are provided. I provided them in a separate document as well. Here, NPVs and so on. I don't need to go now into details. All the calculations are there. You literate people who read that.
Can we send an email of this presentation?
These emails, these things will be on the website of UNEC, and I'll provide you with a hard copy here. Not hard copy, but image. Może? Yeah. And so these things are available, static thing. But this is the examples of different methods to calculate, but the most important thing, colleague, is discount. All these things are to calculate you as a capital investor, your profits, your capital return. Bank is not interested in that, bank is interested in other things. So just to emphasize that, and here different examples goes there. Financial appraisal, that's important. How you do financial appraisal of the project? And here, and so mentioned shareholders' equity is mentioned here, debt to equity ratio, and shields, tax shields. It's not applicable here, but just in case if needed, it's here, and so financial appraisal from point of view of the bank is also provided. So you'll have a copy of the guide if you're interested to read it. Please do. And if you have comments, I would very much appreciate that. I would very much appreciate your comments now and currently. So David, the service coverage ratio is explained here. And this is the free cash flow. This is the operation profit. Depreciation, amortization, this is the tax reasons. Increase of working capital if you need to borrow more money. Capital expenses, less tax, because you have to pay tax. And fixed charges, this is the debt service, is the low principal plus interest, or if you have mandatory dividends. Some projects, they require that you pay dividend. So some banks and a big projects calculate loan life coverage ratio. It's very interesting. For the life of the project, the cash flow generated is enough to cover the loan. It's a very interesting concept. Very interesting concept. You calculate this loan life coverage ratio for the remaining part of the loan period. Would the project generate enough cash to cover the loan? But of course, the cash you get has to be discounted. The discount rate is the interest of the bank. Because the cash is actually discounted with the interest you have to pay the bank. But this is the discount rate. It's a 7%, you discount the 7%, the cash flow in future, and see if the cash flow in future discounted to 7% is more or less than the loan they have to pay. For example, they borrowed 100,000 euros and we discount the cash flow, the interest rate of the loan, and see if this is more, all right, they have enough cash to pay. If it's less, so no, they'll not generate enough cash to pay us. So the result, by the way, is quite similar to debt service coverage ratio. Same ballpark, approximately. I should be more than 1.2, usually. Because the people have to have enough cash to pay the service of debt, put some reserve. Did you get that one? Loan life coverage ratio? This is for you, because you need to know it, but the banks need to know that. Okay. That's all right. Thank you. And the banker advice, when they tell you something, what you do, we try to explain these things. If they say, look, you need additional equity, they tell you 50% is not you need it. So you have to decide what. So when you have this response from the bank, how you react, what you react as a project. So we try to do that. a small goes there. And after that here, the approval, we explain the banking procedures in brief, which you know, and here is the form actually. Explanations on the form, which you provide what you write.
Yes.
Each item corresponds to the form which provide in Word, and it explains what we have to write. These things are obvious. Legal name is legal, not how you call yourself, but this is very obvious. So this thing now to the end goes and explains the guide explains what to write. On each of the items in the form. Yeah. For example, how you find new customers? If you're producing things and you have to sell them, you have to explain even that. Because the bank will be interested. How you get your customers? What's your market plan, whatever they call it? And who are your customers? What's your position in the market? Are you leading? You have competitors and so on. So these things you have to explain. And risks and so on. As I mentioned, this is the form, and this is the guide how to complete these things point by point. Point by point. And here, for example, revenues, you have to explain what benefits the person gets. From the examples here of different benefits. And you have to write them. So the bank understands that. It's also for you to understand where you can get more value. Yeah. For example, you want to buy a new, more efficient machine, produce something, and you say that I'll have low energy consumption, more efficient. The machine is more efficient per unit of production. And I'll have lower labor requirements because this is an automatic machine. And I'll have fewer rejects. Produces more efficiently without and throughput rate, savings in floor space, all these benefits, which you may think are obvious for you. Because you know how the machine works. Don't assume that the bank knows about that and they're obvious for the bank. So please, you have to write this. Because this is the benefit, and you have to explain. You have to explain. This machine is smaller, much more efficient, produces less changes scrap, uses less materials, it's more efficient, uses less floor space, so I can put two machines. For example.
That changes the discounted cash flow.
Absolutely.
Everything, because if you put monetary values there. Yes, everything.
So I mean, these things, they look obvious for you, but they're not obvious for the bank. So you have to please. So these things are provided in detail of the guide. You read it. When you come to what I have to write here, you get here, they ask us to write this, and that. So whatever is relevant to your project, you put it there, and you put numbers. It's very important, because I say you prove it. But in the machine specification, it says how much it says. So you have to use the numbers. So these numbers you use to calculate the revenue. But this is export promotion, import, and so on and so on. All these things, whatever, right? Who is going to finance the project? If you want partners, if you like other partners to provide capital, or you want to evolve. Because here you borrow from one bank and so on. But when you finance big projects, you have a mandate, you have a charter. For example, EBRD cannot finance more than 35% of one project. And most of the banks can finance. No bank finances the full amount of a project. This is a separate, this is credit lines for specific purposes and so on, it's different. But in a normal life, the banks, of course, they have to syndicate their loans to provide big projects. Because to provide all the full amount to. Thank you. And so you have to explain these things. And here is the project cost. It's just an example of project cost to fill raw materials used and so on. So all these things I explain into the how to evaluate the costs of this, because they have to be proven. You cannot just invent. You have to specify the costs. Okay. Some costs are very eligible, some costs may not be eligible. So of course, in the form, specify that. Financial fees, here is examples, of course, the bank charges some fees, as we agreed. You have to count for that, whatever fees, but I here provided some examples of fees. For example, very often in these big projects, if you plan a disbursement, but you don't borrow the money, for this period you haven't used the money to earmarked for you, you have to pay commitment fee because the bank reserves the funds. I don't think this is applicable in this case, but do you charge a commitment fee? No.
Your plans, no. Banks pay banks. Banks pay to the EBRD or.
Oh, yes, yeah, the bank.
National.
Yes, but not
Development bank.
Yes. Otherwise, yes, they reserve the funds.
Plans sometimes in some banks are used.
Yes, this is
Same revolving.
This is
На рамки.
На неискористимиот дел од рамката.
Да,
Искористен дел конкретно.
Commitment. Yeah, this is a commitment fee. And you have the cancellation, repayment, guarantee, maintenance, reimbursement, and so on. So you have export credit finance is specific, not applicable here in this case. So just to let you know that when you use that, because this is a universal guide, it's not specifically for small projects. This is any project. So colleagues, it continues like that, procurement and so on. You're well versed in that. I don't need to. Product and services that have to be described, what you use, and so on. And financial position of the buyers, very important. Creditworthiness of the buyers. They're not good, they will not pay you. And this is the regulations, permits, so on, all these things. I'm just throwing to you because it's very long, and if you have any question, obviously there will be later questions, so please ask. Here what the loan, the role of the bank, there may be lender, lead, lender, arranger, syndicator, underwriter, and so on. In this case, that's simply lending bank. But if you have to structure the project and you know that it will be financed by several banks together in a syndicate, you have to write these things. These different types of finance, the life of the project, and so on. So it goes like that to currently source of finance. You need to write this down and cash flow. The cash flow projection is usually taken from the base case financial model, and here we describe that. What is included in the cash flow calculated, and examples of cash flow, Same cost, it's not, same cost is the cost which, for example, you invest in advance. It's done there, and you see, I need loan to complete this project. The project of money you invested in advance, sunk cost, they're sunk, they're gone. So the bank say, all right, that's fine, but don't count on this money, you invested them, they're gone. Sunk. Opportunity, cash flow, strategic options. We try to be as detailed as possible. Project. Scroll to the end. The interest and so on. This example of a balance sheet. It is a pro forma financial statements you need to do. Net book value and examples. And ratios you may use, forecast ratios. In this case, you don't need this gross profit margin. This is for new investment projects for production. Gearing and so on, asset test, you don't need for. But they provide here as an example of overall projects. And then you provide this checklist will provide it for supporting documents which are usually required. This is for big projects. It's not for standalone projects. This is example, this what thing you may require. All the safety of permits, testing, maintenance, so on, insurance agreements, bonds, because here you have performance bond, for example, the project performance bond. If the project doesn't perform, they pay whatever amount is agreed to you, so you can service your debt because the project doesn't perform as specified. So these type of things, the guarantees and so on, usually this this is, for example, legal opinion. Very difficult thing. Standalone project, you need a legal opinion from the government that this project is legal. Operate. And it's a very difficult, very important, very good lawyers to go and talk to the relevant branch of whatever provides you with the legal opinion. This for standalone big projects. And so this is the reference books here. So this is in brief, this is the guide which provides you how to complete the forms, application forms. So when you go, understand that this application form explains everything about the project, provides relevant data so the bank can do their financial appraisal, a technical appraisal, whatever they need to do, and approve your project. That's the point.
Yes.
We make do that, make their life easier. Otherwise, they will make their life much more difficult. So we're trying to help with that. So you have. So let's now shall we look now how this works financially and to show examples of financial models? Okay.
Yes.
Right. Shall I call it? And this is the form, as I mentioned, this is in Word. So this is the application forms, as I mentioned. It's one Russian and one and two. And two forms here provided. Is the business platform for energy, the big one. And this is project identification form is shorter application form, identification form. And you have sorry. We have also these application forms. We have models, example of models. We have also But I'll wait for this tomorrow, we'll discuss this tomorrow. We have to calculate the CO2, greenhouse gas emissions and so on. And I want my colleague Mathieu to do the specification. Already here, the different examples I have to calculate this. I can show you one.
Okay.
CO2, and we'll discuss this tomorrow. This is how we will calculate it. Now, let's go to the example of models. So this is the emissions of CO2, so we look at tomorrow. And this is the models, example of different models for solar and other projects. The big one is some of them are begotten. Some of them, this is a big financial model which is used to evaluate 50 or evaluate and compare 50 products simultaneously. But that could be 150 as well, but 50.
You can share a screen if somebody is online.
Okay, let's upload the project. The model is big, but it follows of, for example, the bank or for you have 50 applications, 50 clients. You can put each of their project there. The problem with that, it's very complicated, very detailed. It's called shadow model. It gets the assumptions from the models of the client. You put these assumptions into this model and you compare the results. And you see, did the client calculate these things properly? It takes some time to open it, so that's the things. Second. No. Listen. Now it's calculating because it's thing now calculates. We used it last time in Mozambique, so this is why it's in Portuguese. But it has option for different languages. So don't be. It's calculating everything. It's very detailed, extremely detailed. You have hundreds of assumptions to put in it. We can do it. So for you, probably the easiest thing is to use English language. English language. So you can use this. You can, if you, for example, update. Well, you can update the sculpting. Sculpting the debt is to make the debt according to the cash flow to fit whatever the bank wants to pay. So it's a very detailed model mentioned. And we choose here which project is, for example, number 2. You select this, and here you have summary and we have assumptions here. And very long.
Share presentation.
Oh, we can share the presentation. Just a second, I will do that. Can you see it now?
Yes, now it's okay. Yes, now it's okay.
Okay, so this project, it has, you enter the numbers and all this, the timing, the dates of when you start, what is your target, when is the completion and operation date, and what's the actual, so this is very important. How, if you have any delays, because it costs money, and the banks know that, so all these things are counted, and it goes these things, milestones, macroeconomic indices, this is the exchange rate, and the hedging, and different indices of inflation in Eurozone, US zone, and so on. You can choose different currencies, and the construction phase. And for example, here you have the equipment, PV systems, inverters, charge controls, all these costs. These items you put there. So it's a very detailed project. This is more for banks, to be fair. You can use it to put all the projects together and compare them, but that's not because the banks need that. So this a shadow model where you put the assumptions of the you have from the client, and you see the results of each of the projects. And financial services. That's okay. And this is now it goes to the operational date and so on and so on. It goes to hundreds of assumptions here to prepare very, very detailed assumption for the project. And here is the electricity generation, which accounts for the degradation factor. Degradation factor in the first year is, for example, 1% or 2%. The second year is whatever. The third year is 0.7%. So you can do all these things, very detailed. So to calculate what is that. And carbon credits here, fertilizers, other things produced, other things you may produce, and so on. You can get different tariffs for different things like capacity and so on, which is not the case here, but there's energy charge, indexation of the tariffs, which is very often in big projects, we have indexation of this. And so on. So not to go to that, it's very extremely detailed project and provides information. So if you're interested, I can provide you with more details on that, but it provides you with this is a summary of the results of a project, and what's the electricity, what is generated, what's per annum, what's the income per annum from energy capacity you sell and so on, mini grids you have, and all these things. But in this case, this project, which number is this? See now, it sells only on one tariff, but you can sell on many tariffs. And you can also get money for providing capacity to the system. Solar cannot do that, obviously, they cannot because they're intermittent, but some other projects, they have capacity because they get money, because at any time they can provide capacity to the grid operator. And they get paid for that. And so a lot of coal power plants make a lot of money now because they can provide capacity. Between plants, yeah, but it provides with all these potential. So here, even the probability scenario here is they selected P50, P50, not P90, P50. Very low risk factor, but it's counted there. And the start of production is 1st of January 24. Yeah? For example, so this is the project summary and so on, and this is the tests. The tests have to be green, otherwise something is wrong. For example, you have a negative color trash balance sheet can be balanced. For example, this checks that funding balancing means that the money you need and the money you have are matched. So you don't have. So this is a very detailed project is provided there, and you can use it if you wish for your purposes. I'll not provide this on the website because it's very large. But if you need a copy, ask CMA, for example, to give you a copy of the project. I can send you.
It's only USB?
It's only USB, yes, it's only USB. So please let me know if should we need it. I'll be very happy. We have a license to use it. And EBRD should probably pay me something. Eventually. So that's an example of a commercial big. Let's our sheet. I'll switch it off. It's a very complicated. I will provide you with the example we looked before. There are a few other project examples, so you can use that. But let's go back to, I will share it now. So the colleagues can see that. Okay, so this is a very simple, much simpler than that one, as I mentioned. And for you to be easier, here you can switch the language if you want to use it. Macedonian is MPD, as they say. And so then the project is description is in Macedonian. So your clients, for example, can use that to write it. Then, if something is wrong, you have to change, please. Translate it. So don't trust my translation. I'll put it back to English. So this example, what it does, it calculates with these assumptions. Yeah. These assumptions, it calculates what is the debt service coverage ratio and the present value of equity, that's nice. NTD divided by equity, so it's 1.9, so almost 2 times the money invest will be returned. So invest 28,000 and you get 53,000 discount into that, which is definitely not bad. After 15 years. After, that's a very important, the horizon of your evaluation. Because if we go down here, I calculated this for, can you see it now here? For 15 years, the NPV is 53,000. And the internal rate of return is 24%. Very nice. 10 years is 25,000. 5,000 and the rate is 21%. For 5 years, because the loan is 5 years, you get negative. Because you pay your loan, obviously. And your return rate of return is negative. Very important to choose appropriate horizon of your evaluation.
It's a profit or it's a difference?
No, 53,000 is your net cash.
It's a net income. Now it's inside.
On equity. But this is on equity. The economic internal rate of return is 19%.
This is the whole
thing. The whole thing, if you invest by 100%.
Yeah, that's
And we did
150
90%.
with 150,000. And here you have only 30,000, right?
Obviously better, but as I mentioned, the horizon is extremely important. How long? 15 years, you have time to pay your loan and to accumulate some cash discount, but still it comes. But 5 years, you pay on your loan. And you get not much. Not much. You can see, you have dividend of, you invested, whatever, 30, 40,000 invested here, and you get a month 200 dividend, which you probably will not be you not be allowed to take out. Because you have to meet other right.
This is per month, right?
It's per month.
So
That's per month. That's per month. It's first month, second month. And of course, the whole thing is fine, but as I mentioned here, you have this the process to 78,000. I felt very optimistic, to be fair. It's 80,000 for 100 kilowatts. It's optimistic.
it's high.
6,000 for 100 kilowatts. With the inverters, with the substation, whatever.
It's not substation for a 100 unit substation.
For 100 kilowatts, you need something.
It's 0.6 per power.
It's not calculated. 0.6, but this is theoretical. You have other costs.
No, this is even high.
As a kilowatt.
Human production.
For 100 kilowatts, you need a transformer to connect it to the grid. You need all the.
Usually there is, I believe this is some roof construction.
No roof construction, 100 kilowatts. голяма кръща. И голям покрив.
Не може. До 40 условно.
Ама той е за просумер. Той е друго. Той е друга. Законска регулатива. За компаниите, що са в свободен пазар, може колко загадат.
И на въпрос?
Да. Колко ще ти да, колко ще имат техническа може.
Технически трябва да има.
Ама има много крове с това.
Добре.
27 мегаватт.
Какво?
27 мегаватт.
27 мегаватт. Имаш, защо да не?
Няма колко мотивирани.
Има ограничение.
Имаме 27 мегаватт. Повечето е кладъци.
Що има поставено? Да, има.
27 мегаватт. Хектар или 27 или квадрат или...
Ама он има своє.
Толкава кала и...
О, идея. Я че взял? Сопротивляваш. Огромна е, ама 27 хектари, аз нямам в главата перцепция е много голям.
Той аз го замислям, но не можем да го
Иначе, като влезеш, откъде си до хектари?
Той е много.
Ако имаш 20 мегавата, трябва трансформатор.
Не, има 27 хектари.
110 киловолт. 110 киловолт.
Bogate. How you install additionally 10 megawatts and you are managing with the existing transformer of the building?
No.
You need a special transformer for that.
Yes.
It costs money.
It's special transformer.
But usually these 100 kilowatts, I believe they're installed on the current transformer.
Yes.
Which is.
Yeah,
we can receive the.
The transformation is here.
Yes.
Here,
And if the distribution company allows you to do that, that's the problem. If you have a standalone, you need to do that. No, I wanted to show something different now, something which you need to mention. That, for example, we need to look at the sensitivity of the project to different things. And I prepared 3 scenarios. And we can change here. You don't change anything else there, but you want to do that the cost increases. We say 78,000, but actually, because China is in dispute with United States, the cost of panels goes up because they are Chinese. Get that. And the inflation is up and these things also increase. We don't. So let's see what in scenario 1 will increase cost overrun with how much? 10%? 10% is 7.8 thousand. We can do 10, 20%, see what the impact is. Okay. That's 20%. Then, as you can see, immediately your NPV goes down. What goes down? Net present value. Scenario 1 goes down. And your IRR goes to 18%. Because you pay for it. You pay for it. Cost overrun, ultimately, you pay for it. From your capital. The bank usually approves the loan, you have to go back to the bank. I want to increase the loan. This is very difficult, and very often the banks don't allow that. They approve this project with these conditions. Any cost increase, you meet it. Okay, so immediately your returns go down. Fine. Let's see in a second scenario that, for example, the production goes down. It's very important. Bad year. It rains. Started to snow in November. And the year next year is cloudy. You don't know. It goes down. If it goes down 20%, now the project is fine. 10%? 10% is not very much, but still is okay. Let's see 10% decrease of production. Now, immediately, however, your rejection. Debt service coverage ratios not very good. That's it. The bank will not approve it. You think are more or less fine. You still will get 18% return. But you will not have enough cash to pay your loan, service your loan. And this is only 10% reduction of your production. Only 10%. Because so very sensible. Loan 5 years. 5 years loan. I think it's 5 years. In this case, you can extend the. Exactly. So now it's a 5-year loan.
Yeah, 5.
If it is 5 years, no? Let's do.
Go to 7,
it will be
acceptable.
7 years time, will be how much? 80. And of course, it goes nice. Goes nice. But of course, your IRR, of course, will be down because they borrow more money for longer period. Not more money, but
Same money, longer period.
same money, longer period.
Have more interest.
Okay? There you are. Another option is you increase your equity. Now it's what is this? Now it's 35 to 65. But you can make 40%. But of course, this is more capital, and your rate of return will go down. There is variable cost up. It's interesting to see what happens if the interest rates go up. Now it's 162, which is very, very, very good. But if the interest rate goes with what? 10, now it's 5%. Or let's put
8%.
8%, 7%, 8%. Still, the project is okay, and well, it's interesting if what will happen if the situation goes bad in the world, wars continue, and so on, and interest rates go up, low GDP and so on. And if they go with how much, 10%, 10% will be what, 0.8%, we'll make it 15%. 15%. Let's see what's the impact. It's not terribly big, not terribly big impact. This is 15%, but 10% decrease of production is seriously bad. Anyway, so this variable cost also. This if the cost here we don't have variable cost. Sun is free yet. We'll start charging free, not yet. Still free, but if we have a production, produce, we need to pay for that. The variable costs go up, will of course affect. So as this is the example of sensitivity analysis. So you can see what you can do. So in the worst case, if we do here now 50% increase combination, 10% of increase of cost, 10% decrease of production, and so on. You can see that the project, even in this, is livable. Yeah, we can still manage it, and 15% increase of interest rates. Still, the project is 160. Not great, but is. So, colleagues, just a simple example of a very simple model to see what happens with the project. And of course, we can change a number of things here to see how this works. For example, I didn't change the price per kilowatt. I put it now as 20 cents, for example. 20 cents. Is this realistic price for consumer? 20 cents, 20 euro cents.
For what?
For electricity. For solar.
Depends what are you talking about, commercial or households?
No, this is
commercial. Commercial is about 100 and it's variable, but 130, 150 right now, euro per megawatt hour.
So this will be 13 cents. 13 cents.
13 cents, yes.
13 cents, then of course we have problems. Because everything goes negative.
No, this is negative, that's why either it's.
Goes negative, but don't worry, maybe my price is too high here, you said. It is 60,000 as you said. 60,000.
Okay.
Let's see what 60,000.
Terrible.
Not very good, but this is 60,000. 6,000, not much. Not much, and I think this is very little expenditure per month. 850 is the salary of somebody maintaining it, which is probably right, that, but if you have to change inverters and so on, broken and so on, it's not very much. But this is, so Colin, this is your base case model. And it shows that, I mean, the sensitivity is not very good. And IRR on equity is 14%. Then probably one of the solutions to get, instead of 84 months, get to 120, 10 years time, 120 months.
There's 10 years.
10 years too, yeah.
Not to. Okay. So then you have the price of it. So 10 years loan, with 8% and 35% equity. So we can go to 30%. Let's check that. Yeah, 30% equity, fine. And 70% loan. Okay, so yeah. Not bad.
Yes, 11,000.
And you have 126 debt service coverage ratio, which is fine. And you have 60% return on equity. And capital enrichment ratio is called. So he invested 19,000 at the beginning, but at the end as an NPV, at the end you get 11,000. So your capital enrichment ratio, 10% discount is not very good. It's less than dollar on dollar investment.
Wait, that's
This one. NPV divided by equity. Advance is 11,000. And IRR on equity is 16%. Not bad. Economic rate of return is 12%. Okay.
see, even in the 10th year, there is no, it's
Of course not.
negative even after 10 years.
Of course, in 10 years you pay loan.
Even more, but some
10 years you pay loan. 120 months you pay loan. Of course, your NPV will be negative.
break-even point is somewhere 10.5 years.
Yes. Yeah. And then you have 11. And here you have 5 years always negative, and in 10 years you have 6% rate of return, and in IRR will be 60% of 10 years. Here also, I didn't show you that. Here I had a price adjustment. But if the price is fixed, this stays the same for the same budget. I have to put at 0. The picture will be even worse. Then, because the price is not adjusted, but you have inflation and you have degradation, 0.8% degradation, which eats your revenue every year. So your revenue goes down all the time because your price increases. The salary of your workers, they go up every year. This year, they're 850, but next year, they go to 893. So they say, look, I want higher salaries, inflation of 5%, you have to increase my salary. And the cost of materials, everything goes up, obviously. So all the revenues goes down, and suddenly, suddenly you have a negative, you can't pay the loan. You have negative NPV, you have negative, everything is negative. If we don't assume that the prices for electricity will go up, this thing, price adjustment goes one, updates the prices for electricity. Because with inflation and so on, probably they will increase the prices. So this is why then it goes. Another thing which I want to describe is the start of the production. For example, here we have from the first month, they are ready, we give them the money, and they just install them the key, which is probably helpful. But if they need, for example, 6 months to complete that, I will have to put, I put up to 12 months, let's see, set 12 months, so delay of production. And I will say that they're delayed by 6 months. And then, as you can see, the situation changes dramatically. 6 months later, 6 months you have 0. Yeah, as you can see, revenue, 6 months, 0. Nothing. And in 7 months, you start production. But you have to pay your interest rate. Your loan you have to service, and you pay your 850, no matter what. If the bank is very good and you say, look, I can't pay it, you can capitalize it. And you can ask for grace period here of 6 months. 6 months, then you don't pay 6 months. Okay? So in the first 6 months, you don't pay your loan. Your loan is here for the first 6 months each year. This is the grace period, you don't pay. So the solar projects, colleagues, even with a very optimistic assumption of 60,000 per 600 euros per kilowatt, still is very difficult to be fair. But it can be done, as you can see, 10 years low, 8%, it works. We can stay for longer here because it rains. So I'll be happy to. I'll be happy to. So, colleagues, any questions on that? If you want to see how this works, for example, for production of different things, production here is now is 0, but says 0 here, and then we can say that you produce 20,000 of something, and these 20,000 things costs €1 each. And generation of energy, and you save some energy. You can save some energy. For example, 10, 20,000 per year, it's up to 20,000. Saved in this case, not doing it. And your margin is 70%. 70% here. Unless to this type of production, because you buy a machine, you don't need 6 months, probably need 2 months only to install the machine, operate it. And and this machine costs 60,000. So probably need to do something less, probably cost 30,000, something like that. So this is quite profitable in such situation. This is an example of mixed project. You buy machinery which produces something, you sell it for €1, and you make on each cell 70 cents profit. Very optimistic, obviously, because probably the variable costs are higher, for example, 50%, 50% margin, which is still good. And still the project is quite profitable, it works, it saves money. Sell the equipment, you sell the produce, and so on. And this is how the project works. This is how this model works. You can use this very simple model for evaluation. If you have better, I provided a few examples, please feel free. This is to illustrate how these things. But this is a quite nice, profitable project, which you and yes, 21%, 20%, 1% economic rate of return. It's quite good. It's a long term, and we don't need 10 years in this case. Probably you can do it for 6 years, 13 months, maybe. Yes, you can do 6 months, you can do even 5 months. 5 years, 6. Yeah, you can do it for 5 years, you can work. This is a model. It assumes a lot of things which we don't know. But it provides you some guidance where you start. Alex, I'm expecting your questions. This
What do you have with this CO2 tab? There is a CO2 tab.
The other sheet.
CO2 you have to calculate, but I will talk with this tomorrow. Tomorrow we have to calculate the carbon dioxide saved, greenhouse gases.
Are you talking about CO2, like CO2 or CO2 equivalent?
Equivalent. And I looked at the electricity, your factor for electricity in Macedonia is on each kilowatt hour is 0.514 grams.
Where did you find this? For electricity?
The reference is up there. So you can see probably this is an electricity map, I imagine, of zone of Macedonia, and it provides you that. But we'll discuss this tomorrow. I provided a few examples of calculation. And my colleague Matthew will be here. He'll, because we have to use the same with him as verification. So I don't want to discuss this. It's here because as a part of the application form, you have to fill how much you save or project saves. Because this is one of the conditions which EBRD is asking for project to save.
Я бы как раз оставил органайз. Да и даже и коорган.
So some projects are profitable than the others, as you can see. Solar projects are very slow return and they're highly dependent on the cost.
The average payback period for solar plant. Payback period, average payback period.
I didn't calculate it yet, because obviously the bank is interested to see their debt service coverage ratio, and we're interested in your return. But a project which have probably more than 7 years. But the banks can accept loans up to 10 years, as we understand. As long as you pay, more you pay. More you pay. I provided the end here. For example, now you borrow from the bank 21,000. 21,000. But at the end, you pay 5,000. Yes. So you pay 7,000 loans. It's not much for 5 years, right? But you have to accept you pay to the bank because the bank has their risk. They value their risks and they charge you interest rate. If you have probably better borrow, they can, instead of 8%, they can offer you 7.5. But if you are not very don't look very well, and so on, they can charge you 8.5%. So to them, we charge you, this is their reward. They evaluate your risk, because they have to make a provision. Lending is not so simple. They just, they buy money from somebody else. They have to pay this money back. So their margin is fixed.
It's 400%.
Yeah, all right. 100%.
No other business, no other business in the world.
400%.
400% is the margin.
400% margin.
100%.
On what? On the money they bought?
Margin, the margin. For the banks have 400% margin.
Margin on what?
On the money that they are deposit on the deposit. 400% is the average in Macedonia. In Europe, the average is 130. In Macedonia, it's about 400%. On the margin, net interest margin between the deposits and the loans.
Of course, they pay very little on deposits. Yes, they.
Yeah, but I'm saying the average in European Union is 130. In Macedonia, it's 400. In the biggest net interest margin in Europe, one of the biggest, you have Hungary. It's about 350. And Germany, for example, has 100%. 100%. We have 400%, and we are doing much better than Germany. You know, GDP, interest, profit and everything. So that's what I'm.
So you feel rich?
Yes, we are rich country.
No, it's not, they.
Че да се постим. Нема така бизнес у друг, кажем, бизнес ще има 400% маргина да има. Например, ти имаш маргина у бизнесу 20-30% да речем. Я имам 15.
На всеки ден
Бозите има 400.
Сметаш камата на депозит и камата на кредит. Тоците се малку пред 2 години, може да го кажеш.
Колко е сега?
Се смена много. Ланска година порасна много кама депозитите. Депозитите, защото после е комерцијална. Сите други банки буквално имаат проблем.
Сега мислам дека е дури 600%. Сега Павле Гацо збореше сега пред месец дена.
Депозит 5%
Не, како не? Ајде. Немој да 8% се
кредит.
На кредит.
Не на комерцијална банка имам кредит. Депозит.
Комерцијална само не пачва депозити. По комерцијална се максимална на изгубите.
Што се тоа?
Други банки се проблеми се борат на малку што депозит. Само најниско ниво е каматата на депозит. Нема потреба. И нема потреба да ги катуват каматите за да привлечат. Ова од пред 2 години, негде 2021, наеднаш сите банки почна да ги катуваат каматите да се тркат во не ги интересираше банки депозит.
Не сакам сега, ама Народна банка ги има по квартал ги води. И ги има и за сега, знаеш. Обаче проверам вечер.
Во статистика ги има.
Ја мислам дека е по 400%. Народна банка многу тешки праја, ама Народна банка е ужас.
The banks don't lend deposits. Many deposits, they get their capital ratio, liquidity ratio. Banks in Macedonia have very good liquidity ratio. Because they don't lend it. They lend borrowed money. But in this case, they get money from the EBRD credit line and they only lend it.
Okay.
They don't lend the deposit. Deposit kept for liquidity ratio and they kept with the central bank. Please, don't get.
Some banka has
Yes, some things, yes. Something. Yeah, they have some kinds of. Most of the money, yeah, most of the money are bought on the money markets.
Treba kreditna linija da isplaćamo ne subiramo depoziti što je. Da treba da isplaćamo kreditna linija.
So if the bank, because the bank for each loan makes a provision. Provision is your money, you put them in a special account, provision, you count them as a loss.
Yes, it's accounting.
Yes, accounting.
Accounting terminology, that's the provision. At this moment, I think from new year, there will be change in the provisioning of the national bank regulations, of the provisioning, and will be more expensive. Yes. Yes. And for money transfer, for small delay, the bank has to take a big part of the profit as a loss. The banks have the impact in the beginning, but after that, I think the companies and the private individuals will suffer because they will be in that category.
Yes.
So when you have bad loan history, it's calculated according to the provisions. You have been in delays twice in last 3 months. No more than 30 days, but you will go to B category. B category means that you will pay higher interest rate. And also at the bank, I don't think we would give significant loss for a bank that you delay 30 days. It's nothing. 15 years when I started working in a risk department, up to 90 days we are not calculating provisions.
You should ask Basel.
Basel and this standards.
Ultimately, the borrowers will suffer on that. Ultimately, it affects them because they have to make a provision. The provision goes into their balance sheet. The balance sheet, of course, is bad. To keep it better, the bank has to charge more.
And we have to increase this the margins.
The margins are right. We are one of the worst in Europe. That's in terms of percentages, that's.
Тоа збориме дека од нова година уште по-лошо. Зашто ако банкава имат поголеми резервации, загуби книжит, ти имаш лоша кредитна историја на това. Што од МКБ извештај за тебе личен дека ти имаш резервација 10% за кредит, зашто ти каснал 2 пати 30 дена. Така 30 дена си каснал, автоматски ќе плаќаш 9%, 10% камата на потрошувачки кредит, нема за тебе да следуваат со 5. А депозитот пак ќе остане со 3.
Ама депозитот не.
Може да земе, може и да земе алкалоиди. Ама како алкалоид има ако 3 фирми у земја.
Алкалоид. И не му треба.
Ама чекај, зашто мора автоматски да го префрли у фирми?
Да, по директива од Народна банка.
Тој не сме да земе после со.
Може да земи, ама нема да му ама немаш новиот кредит кој ќе му го исплаќаш, не му треба да ставиш 10% или 5% резервација. 5% резервација значи 5% од главницата, ако земаш 10.000 евра, 5% како и да ти е 500 евра загуба книжи банкава во стартот кога го исплаќаш кредитот. Како што го отплаќаш кредитот, така ослободуваш од таа резервација. Шом го исплатиш цел кредит, сите 500 евра одат како профит. И фактички при исплатата банкава директно
за тие 500 евра, ако ќе се отплати до лицата сама луба.
Оде, ама ќе најдеш зборам сега. На пекарија плаќаш за така се
Because they count as a loss.
Сметководствена категорија се повеќе.
Точно за банките, за другите никој не беше. Ама ќе ги ослободат, тогаш.
Ама во моментот кога ти дават тебе кредит, си кредит. Банка, така, јас сум банка, ти давам 10.000 евра, 10 евра загуба, зошто? Давам 10%. А на овој што имам 1% резервација или 0,1, не може да му дам со 5%. Това важи. Од нова година има затегнување ново, иначе ова важи цело време. Но
Ако се креира
строги регулативи во однос на кредитен ризик. Провиженинг, резервација.
Да. Просто малку да е лаба, кај не се затега.
Yes. We're done with this free discussion, please. So please, the bankers will say a few words about that. They keep quiet, they don't want to divulge their secrets.
Understandable.
Yes, but this is a very simple model, just to finish it, very simple model. You can use it to evaluate the financial performance. Very simple model, month by month. And so you can see how the project works monthly. Because most of the other projects, they're annual. Projects, they show you the annual payment of is annual. Here I put it in monthly because the banks. So what is deliberately done. Calculate. A lot of projects are annual. This is 15 years horizon maximum, as you can see from this. This project, which you look at the example, looks nicely, even for 10 years, it's okay. And one thing I mentioned is that the discount rate and the internal rate of return are calculated. Here, the discount rate is 10%. If we put 21.6%, which is the economic rate of return, you get a net present value of 0, theoretically. So for this, you are 21.6%, so that's 21.6. And NPV for some, NPV is for some reason it's not 7,000, but it should be 0. So see why it's not. Oh, this is yes. It's 32% because not overall, but the return on equity, NPV on equity is 0, so it's 32%. So if I discount the cash flows of 32%, which was my return on equity, I'll get the NPV of 0. 32% return on equity, 32% discount rate, and you'll get NPV of 0. That's the rate discount is calculated. I was good. But 32% is very high.
It's very high.
Probably,
It's not crazy.
I can discount.
Yeah,
But usually it's around.
No, wait.
So it's, thank you for your attention. It's very, I think tomorrow.
You know, also for concentration. Speak about this.
Thank you all for your time and attention. It has been a long day, our first day of training, so we heard some very useful information and very practical and to the point experience shared by our consultant. Thank you, Mr. Dotra, once again. Looking forward to our tomorrow's session as well. Since we have the upcoming OSCE summit, which is taking place in the following days, we received information that there will be some restrictions in terms of the commuting. So the plan is to start the morning session as initially agreed tomorrow at 9:30, and then we'll tomorrow during the course of the morning hours we'll decide as to which option we will follow in the afternoon hours, or whether we would decide to do the afternoon hours through the available Zoom links, or we would decide for those of you who want to opt for physical presence. Of course, UN House is always open to greet them in meet. So see you tomorrow at 9:30, and then we'll decide of the afternoon session.